Good morning.
Good morning.
It's not time to start. Y'all got about 5 minutes. I just wanted to let you know. Take care of anything you need to before we get started. You got about 5 minutes. Two-minute warning now. 2 minutes. All right, everybody. Good morning.
Good morning.
Well, Everybody find the place okay? It's not like we haven't been here before, right? So what we're going to do first is I'm going to ask Ms. Deborah to gavel us in, and we're going to go around and do introductions. So she's going to start and show us how it's done, and we'll just go around the table.
Hello, everyone. Deborah Creech, Chair. This meeting is now called to order.
And James, if you just introduce yourself, real brief.
James Shedd, cab member.
Wanda Jackson, cab.
John Richards, UK Region 4 liaison.
Madeline Kellett, South Carolina Department of Environmental Services, Midlands Aiken office.
Heather Cathcart, South Carolina Department of Environmental Services, Columbia office.
Edwin Deshawn, DOESR manager.
Louis Priester, cab.
Tanya Moulton, cab.
Pat Kilroy, cab.
And Dell thinks she ran away, but we're going to make her do it when she comes back. She doesn't know that yet. And my name is James Tanner. I work for the Department of Energy. I'm your DDFO facilitating the meeting today.
Your mic's not on.
Oh, man. There we go. Is that loud now? Okay. I guess I'll do it again. I'm James Tanner. I work for the Department of Energy. I'm your DDFO, and I'll be your facilitator today. To get started, let's kind of take a walk through the agenda real quick. Deborah's going to she may have a few little updates that she wants to give us. We're going to go through agency updates. That's going to be DOE, EPA, DES, the state. We'll take a short break if we need to, and we'll run into some liquid waste presentations. For those of you who are with us at orientation and went on the tour, these are the facilities that we mostly saw. So think about the tank farm, DWPF, SWPF. That's what we're going to be talking with the first half of the morning, okay? Then we'll run into the legacy true waste disposition. We'll talk about historic preservation. That's going to be everything from the Cold War to today. After that, we'll take a break for lunch. We'll have a little bit of voting for a cab vice chair. We'll go into the state, talking about their role at Savannah River Site. We'll talk about EPA's role at Savannah River Site. And then we'll do the other end of historic preservation, and that's archaeology. So that's going to be about 10,000 years ago to the Cold War. So they got a little bit of a longer span that they go through. We'll do a little bit of board business, especially since we have 7 board members here today. That means we meet quorum. We're going to be able to discuss and vote on stuff. We have a chair's recommendation that we're going to talk about, which is a little bit different than what we normally do. And then we have a budget priorities letter, which is a little bit different than what we normally do. The big deal with the chair's recommendation is, you know, normally we take a little time and we edit and finagle and we play with the wording and we try to wordsmith a little bit. This one we can't. This recommendation was written at the national level by all the chairs and vice chairs of all the advisory boards. They've already approved the wording, which means when it gets down time for us to discuss and vote, it's either going to be an up or a down. You're either in favor of it or you're not, okay? So if you didn't read it when it came through your email, it's in your packet. Make sure you read it today, preferably during a break, please. And we'll make sure that we get everything covered. Dell, we went around the room and I promised that we were going to introduce you when we got back and that you didn't get away from it at all. So real briefly.
Dale Priester.
Thank you.
Y'all hear me?
We can.
All right.
All right. Okay. Deborah, do you have a few words you want to start off with?
Just want to briefly tell you, and again, didn't get a chance to speak to the cab board when we took our trip to the Hanford site. It was an enjoyable trip, got a chance to learn a lot, had an awesome meeting with all the local cab members there. They gave us an update on the budget update. We came from budget and planning information, national environmental policy update that they did with Aaron White. They gave us an awesome update regarding reuse and recycle community of practice by Shannon Chester. That was awesome. We had also an update on waste isolation pilot plan overview by Mark Bollinger. That was awesome. With that information, it carried on to an update by Greg, I think, Sosson, update on Defense Nuclear Facilities Safety Board. We had an awesome time. There was much information that was given, got a chance to meet a lot of the board members. They really fellowship with us, gave us an awesome time tour. I didn't get a chance to take the actual tour. I missed that part, but I did get an update on it. And the areas that they took us in for is the wine gallery. It was just beautiful. But the information itself that they gave us and the updates, it really explored my mind and updated us in the community, bringing things back here to our CAB meeting, Savannah Riverside. And I am so excited for what Savannah Riverside here is doing in Aiken, because it seems like we are really doing an awesome job when I listen to all the other local board members and listen to their update. Savannah Riverside has really done some outrageous stuff that it blows a lot of our mind when we get to talking about the information here at Savannah Riverside. So I'm so thankful to be a part of the CAB board here and then getting that information from Hanford side, being able to compare.
All right. Any questions for Deborah about her trip out west? Seeing none. All right. We okay to move into agency updates now? We'll start with the Department of Energy. Edwin?
All right, good morning.
Good morning.
Yeah, I want to go on a trip like that. That sounds really interesting. Thank you for sharing that. And I'm here to touch my heart to really hear how effective it was, and for you guys to collaborate with all the other sites and then come back with a recommendation. So thank you for sharing that. So I do want to say good morning again. Edwin Deshawn, Manager, DOE-SR. Welcome to Aiken, South Carolina, and welcome to the Advanced Manufacturing Collaborative. We're definitely excited about all the work that's being done here at Savannah Riverside. You'll hear about all the great things we're doing, but we're really proud of our workforce. Right now, we've got over 13,400 folks doing all kinds of missions to help the United States, so I'm just really excited to talk about that. First, I'll begin with our site programs and projects, beginning with the Savannah River National Laboratory. SRNL consistently demonstrates outstanding capabilities in applied science and technology through its support of DOE missions, national security initiative, and contributions to the industry. Some of the laboratory's recent achievements include demonstrating a proof of concept for the detection and tracking of vehicles by measuring the changes in power line emissions in the electromagnetic spectrum. This marks a significant advancement in tracking vehicles that have historically been met with challenges using standard detection and tracking systems. SRNL submitted the draft AI R&D roadmap to DOE headquarters and the Federal Steering Committee. The roadmap focuses on accelerating EM site cleanup at reduced costs through the advancement and implementation of AI across the complex. Through the Savannah River National Laboratory, they reanalyzed glass loading of plutonium that helped H Canyon benefit by accelerating discards and advanced it by 2 years for the Fast Critical Assembly mission. SRNL effectively showcased the use of the Brock demolition robot within the Hanford single shell tank mock-up here at the Advanced Manufacturing Collaborative. The demonstration offered that Hanford dry waste retrieval team a practical simulation of the deployment of robotic equipment in a Hanford tank, helping to validate operational procedures and boosting confidence in upcoming field activity. SRNL continues to grow AMC by adding another cooperative research and development agreement that focuses on developing state-of-the-art 3D printing equipment, facility enhancements, and on-site expertise that will enable cutting-edge research and expanding training opportunities for advancing manufacturing solutions. SRNL continues to be identified as a global leader in additive manufacturing. Mark 18A processing has achieved a new milestone by initiating the simulation processing of multiple target quarters. This advancement will speed up efforts to replenish the nation's critical supplies of both plutonium-244 and curium. And then finally, SRNL has been chosen by the Department of War to sponsor and launch a new initiative focused on developing and qualifying particulate research materials. This program aims to improve quality controls for mass spectroscopy measurements through sponsored networks and analytical laboratories. As far as the budget, a few weeks ago at the subcommittee meeting you received a budget briefing and a request for the integrated priority list. The letter you draft and vote on today will be submitted for community input within our budget request. So look forward to that. Operational progress and achievements, beginning with nuclear materials. LRA continues to receive used nuclear fuel from domestic research reactors for storage in El Basin. In addition, SRS recently received foreign research reactor fuel from Japan. This was done in support of the department's non-nuclear proliferation program. H Canyon continues to make progress with the resumption of systems and process equipment to support uranium recovery. H Canyon's first system to resume operation will be Head Ends, which completed cold runs last month. SRNS expects Head Ends to become operational in September. K-Area continues to downblend operations and has completed its 19th downblend of EM surplus plutonium for FY26. Transuranic waste shipments to the waste isolation pilot plant. SRS has completed 19 of 38 shipments to WIP planned in FY26. 7 were from E area and 12 were from K area. Now to our liquid waste program. The liquid waste program continues to make significant progress, accelerating the cleanup mission. The Defense Waste Processing Facility reached its 30th year of successful operation in March and has produced over 66 canisters of vitrified high-level waste this fiscal year. DWPF poured more than 4,530 canisters in its 30 years of operations. The revised liquid waste plan now projects 7,440 canisters to be complete in the waste vitrification mission. The salt waste processing facility continues to demonstrate outstanding performance, with over 4 million gallons of high purity salt waste already processed this fiscal year. SWPF is on track to process a fiscal year record of about 6 million gallons. The salt disposal units 10 through 12 projects continue to be on schedule and under budget. Construction of SDU 10 was completed in June 2024, nearly 10 months ahead of schedule. A leak tight test was completed in December 2025. SDU 11 concrete construction is complete. Construction began on SDU 12 in April, marking a milestone in the tank cleanup mission as the last SDU needed to support the mission. Area closure. SRNS area closure projects has already completed 49 of 77 FY26 federal facility agreement, planned circular deliverables, and RCRA commitments. This achievement brings the cumulative total of combined milestones and commitments to 4,296 met on or ahead of schedule since 1993. 235F or F area material storage building. SRNS Design Engineering completed the decommissioning conceptual design and is working on the decommissioning detail design for an eventual critical decision 2/3 submittal and approval. Procurement of a subcontract to initiate the in situ decontamination and decommissioning in the field is expected to occur in FY27. Our area seepage basin asphalt repairs. SRNS area completion projects is 80% complete with the FY26 surface crack repair and sealant coating of the over 21 acres of asphalt at the R reactor seepage basin. This concludes my briefing, and I'm now subject to any questions or anything that James. Thank you.
Any questions around the
Table. Pat, let's start with you, sir.
All right.
One question, do you have a...
Hey, Pat, can I get you to do that in the microphone? I know that we all can hear it in the room, but it's for our online attendees.
Okay, sorry.
Yeah.
It's okay.
I'm gonna let him slide. He's a fellow Charlestonian, and he's a
I
great
can't
man.
let him slide though, because
Yeah,
people send us hate mail.
Yeah, he's great.
Do we have a permanent place to ship the classified?
So you're talking about the vitrified waste from DWPF, the canisters. So currently, they're stored in our on-site facilities, safe, secure, design, until a permanent repository has been identified. So just to be clear, it's safe, secured, intact, until the federal government determines a final location.
Is there any progress on this? Do we have anything in the future we can look forward to when they'll take this, or is there any word out there?
Yeah, no, sir, I do not know. My priority is to make sure that what we produce is safe. SRMC is doing a tremendous job. We've got on-storage facilities. I'm not sure if they got a chance to see them. They're double stacked, robust nuclear facility grade. So we're good. But once one is identified, we'll definitely follow direction and make sure they're stored there. So,
Okay, thank you.
yes, sir. Thank you.
James?
Yes, sir. So is it possible that the current site could be used as the permanent site?
So to answer your question, I'm not sure if his mic was on, but you're asking if the current location that they're stored can be used as a permanent. I don't believe so. Ultimately, the federal government will determine the repository of end destination. So right now it's designed, we're safe, secure for years to come, but we're waiting on the final waste repository to be determined. So, but yeah, so just to be clear, ours is not a permanent location, but is robust and safe. So, yes, sir.
Deborah?
Just an update, I heard you say something about the AI roadmap.
That's correct.
And it was publicized that the U.S. Department of Energy's National Nuclear Security Administrator to enter negotiation for phase lease to develop a 1-gigawatt artificial intelligent data center supported through the Department of Energy here at the Savannah River site.
Yes, ma'am. That's
so
accurate.
that is awesome.
Yes, ma'am. I was announced yesterday, and if you have not seen it, if you go to DOE, SR, Lookout Data Center, you will see an announcement from the United States Department of Energy. That initiative was led by the National Nuclear Security Administration. However, the site will be the Savannah River site. And so we're definitely excited about that. As you may recall, many of the other DOE sites, Piketon, other locations under this administration have identified and breaking ground a new data center. So we're excited about that, you know, and we're looking forward to great things in regards to that.
Yes, and I'm glad to hear about it because it has become public knowledge.
Yes,
so
ma'am.
that's why I'm asking questions.
Yes, ma'am. Yeah, and I would invite everyone to look it up. It's public information, and we're excited. The company that was awarded that was identified as well.
Yes, thank you.
Okay, man, you well, I gotta watch you. Thank you so much.
You're welcome.
Any other questions from around the table? Deborah, did you have any more? Deborah, did you have any more?
No, sir.
Well, it's okay. I have to ask you. All right, just making sure. Going once, going twice. All right. Edwin, thank you so much, sir.
Thank y'all. Appreciate it.
All right, let's move over to EPA. John.
Thank you. Yes, I'm John Richards. I'm Region 4, which is in Atlanta, and for some of you new CAB members, I'm what's called the FFA project manager. My equivalent for DOE is Matthew in the back, Baker, and Susan, Heather's counterpart, is not here today, but so we're the FFA, which means we're the lead project managers, which means we have project managers that work under us, so, or with us. We're not really the manager over them. But some of our sites are so big, like DOE, that it just requires more than a typical Superfund site would just have one project manager. And of course, a lot of, as you'll see in my presentation later, a lot of support team of hydro experts, chemical experts, that kind of thing. And so actually, most of my team is here today. Some of you already know Jana Dawson in the back and Brianne Martin, and our acting section chief, Elena Famble. She had a nice air-conditioned tour yesterday of Savannah River, thanks to Matthew and his colleague. So I got to see a little bit of the site as well. And also, we actually had a VIP tour June 24th, which I wasn't privileged to come along, but we had, as you know, the top of most federal agencies are political appointees. So our assistant administrator, which I'm not sure the full name, is known as Thomas, and then Steve Cook, that's over the political appointee over our Superfund headquarters, had requested a site tour of Savannah River, which also means, like in our region, those are also political appointees, the head of the region office, which is true for most federal agencies, or all federal agencies. Kevin, I just forgot his name, starts with him. Yep, McCumber. So he also came over, our Superfund Division Director, who actually, South Carolina, we had arranged for, at his level, tour back in March. We got to come again. So they had a great tour and got to see a lot of the site, and they had just been to Hanford, as all some of the other comments. So as far as our activities, I may talk more in my presentation, but we're getting pretty busy. We're kind of in the middle of a 5-year review. For those not familiar with that, Savannah River site is so big with so many remedies in the last 35 years. Again, most sites only do 1 5-year review. They might have 3 or 4 operable units every 5 years, but we've got so many. We've got over 99 operable units, and so many remedies. We have 5 different categories. So I think the one this time, the engineering cover systems, so however many fit under that one is the one so we usually go out and see the site or get a drone review of the sites we're going to see in February. We get the document to review, and then we submit comments from our headquarters, our attorney, us, and we get all those back now, and then it's usually signed somewhere around November, December. So, and again, we have one every year. The other, we actually had quite a few what we call proposed plans, which I'll talk about a little bit later, but that's the big document that goes to the public right before, in this case, the federal agency, the lead, DOE, would choose what we call record decision. That means we've already decided, usually as a core team, South Carolina, myself, EPA, and DOE, on, okay, for this given area, for example, Brianna is doing A area, we've already decided what the contamination is, what we need to do. Here are maybe 3 or 4 options. Well, we've usually at this point chosen the preferred option by the proposed plan, and then it's decided in record decision. So it gives the chance for the public to weigh in on that. So actually we've had 3 of those, and 2 I think Brianne's been over, A area, L area, even maybe D area. She's getting ready to do another. We have to do a lot of briefings in our region to our top manager and our other, what we call I guess a Region 4 design team. In other words, it's made up of people that aren't necessarily know what DOE does. They may work on all private sites. So try to be a little consistent with all of our remedies. And the one recently that I did was on coash reuse. This is one of the big things that DOE has been promoting. So when they finally close those big F&H tank farms, the big salt stone that a lot of you saw on your tour, it's going to require massive landfill covers and fill material. And so there's just not enough fill material. So having as much coash as they have on site, this will be used for a lot of that contribution. So I don't know if I have anything else. And again, I'll be talking later about our actual role as EPA and why we're actually working at Savannah River, why it's in the Superfund site. So thank you. Any questions?
Any questions for EPA from
On the table? No? Y'all are saving them for his slides later, right? I got you. I understand. All right. John, thank you so much. All right, we'll move on to the state. Heather Cathcart. Thank you, Dale. You told the lead. I appreciate that.
Thank you. Good morning. I'm Heather Cathcart. I'm with the state. I am the Federal Remediation Coordinator. So I work with Susan in the Federal Remediation section. Since our last CAB meeting held in March, the Federal Remediation Section has reviewed over 15 documents, such as the early construction and operational disposal site L3 and L area rubble pile record of decision, the automotive repair shop RFI report and baseline risk assessment, and the status of the F&H area radioactive liquid waste tanks being removed from service. We also call it the March 9th report. And the 7th 5-year remedy report for engineered cover systems. We also have attended multiple meetings and site visits, such as the C area groundwater strategy meeting and a site visit to D area to observe drilling activities. Our regional office monthly inspections of the salt stone disposal units and ambient stream monitoring continue to occur, as well as a recent comprehensive underground storage tank inspection of all 7 UST's permits and a comprehensive wastewater inspection of all outfalls, treatment systems, and associated paperwork. In May, the RCRA, or Resource Conservation and Recovery Act, Federal Facilities Group conducted their annual comprehensive monitoring evaluation of their post-closure facilities. Their initial review for the permit application for the Savannah River Plutonium Production Facility will be completed by this fall. An estimated date of the final review is not available yet. Also, a major module of the RECWA permit for the true paths, along with some minor modules, was issued in June of 2026. So are there any questions? Sure, Pat.
Pat Kilroy.
Oh, turn it back, there you go.
There you go, that's all. I was looking through some stuff, this has been a while back. And y'all had sent in a report about, and this is South Dakota Department of Environmental Services. And there was a dialogue in there, and I guess it was passed out in one of the previous meetings, but I was just thumbing through and looking at stuff. And they had this one page, and it showed all the wells. And there was a note on there that the only well that was checked was MO 3113. And I looked, at the picture, and here's all these wells. And I'm thinking, they only checked one?
Madeline Kellett, SEDES Aiken. So that's part of our, I don't know if it's picking it up. Is it?
It is, you're
Okay,
good.
So that's part of our environmental surveillance and oversight program that we have in our Aiken office. That is our groundwater monitoring project. In that program, we talked about it in the subcommittee meeting last month. So I believe, and I can double check, I can pull up the report while we're here. That project for last year was 13 wells that we sampled for. That well in particular, I believe in the report, and again, I will double check it, that was for our gamma detects. So only one of 13 wells tested positive for lead. So all the other wells, nothing came back for gamma. There is another part in the report where we talk about our background location. The background location is the only location that we sample every year. All the other locations are sampled on a 5-year rotation schedule. So there was more than one well tested. Only one tested positive for gamma, but we do also have our results for alpha, beta, and we do also talk about tritium in there as well for those locations. And we have tables that have a 5-year comparison as well.
So y'all do go back, 5 years to compare?
Yes, sir.
And do y'all ever go around and check all the wells?
We do not. So there's 117 locations. Our project manager is not able to go to all of those locations every year. We do have to schedule. Some of them are with DNR. Some of them are on properties that we do have to reach out to for that schedule. So that's why there is a 5-year rotation on those. We do try to get a good bulk every year, but it is hard for us to get all 117 within 1 year.
Without checking all the wells, how can you determine, or I don't know, in what order you use it, but if you don't check all the wells, how can you determine on a 5-year basis that this is increased, this is decreased, strontium-90's up, this is, uranium's down, plutonium's down? How do you make that assessment?
Right, and that's a good question. A lot of consistently since I've been in this role and looking at previous reports, all of our if we even have detects in our groundwater samples, they're all well below standard. Now, if there was a well that tested above standard, we would consider looking at that well a little bit more and looking around that area a bit more to see what's going on. But historically, all results have been below standard, even if we detect it at all. And groundwater tends to move a lot slower than like river water and stream water. So that's why we do it on a 5-year basis, just because there's not as much movement down there. And if there were movement, it would accumulate, so we would see it in that 5-year period.
And my one question there is, how has the standard changed in the last 20 years?
You mean the state standard, like the federal standard?
The federal standard on how much nuclear, or how much, at what rate, has it changed over the last 20 years?
We do look every year just to make sure, like if EPA has a new standard or if there's a new federal standard. We do include that in our report if there has been a standard change, and we base it off our results. to see if there's any concern.
Okay. All right. Thank you very much.
You're very welcome.
Any other questions for DES and Heather and Madeline? All right, seeing none. We're ready to move on. So the next thing on our agenda is a break. How are we feeling? Do we need to take that now? Do you want to move on a little bit and then take a break? How do you feel? You all want to move on? All right. If you'll go ahead and get mic'd up, sir, while he's getting mic'd up. Again, this first presentation that we're going to talk about is the liquid waste system plan, and I'm honestly just stalling for time while he puts a mic on. But for those of you who went on the tour, again, this is talking about the liquid waste facilities at the site. This is talking about how they plan the operations, what they're looking for improvements, and not to steal too much of his thunder because he already has his mic on. I'm just going to remind you that you all saw, those of you who went on the tour saw a lot of these facilities that he's going to talk about. You saw the tank farms, you saw DWPF, you saw the glass waste storage building, you saw SWPF, and I'm going to move out of your way.
Hey, good morning. Is my mic on? Say it. Good morning. Good morning. Hey, so I'm Steve Howell, and so I'm the Senior Vice President for Optimization and Integration, and one of that duties is our liquid waste system plans. I'm going to brief you on that this morning, but a little bit more about me. So I've worked at the site for 37 years, had the pleasure of working across many parts of the site, both canyons, K area, L area, in the National Lab, as well as in the liquid waste mission. So just like many of you, I'm very invested not only in the site, but also in the local community. I've lived here for 37 years. I grew up in South Carolina, have kids and grandkids in this area, so not only am I concerned about the success of the site from a career perspective, but also about what's going on at the site, environmental concerns and things like that, just like many of you. So I share that passion with you. And I'm very pleased to tell you this morning we're making great progress on the liquid waste mission. So without further ado, I'll jump right into the presentation here. Again, feel free to ask questions or as we go through. So just a little introduction here. So one, what is a system plan? And I'd say in a simple word, the system plan is our playbook. Basically, it lays out our plan, our game plan between now and completing this mission. What are our challenges? What is our plan for executing to overcome those challenges, risk, and all those type things. And if you want some light reading one night, you can actually use this QR code, and you can actually, it'll take you to a link online where you can get the full system plan. But I'll give you the Cliff Notes version today, which you'll probably appreciate as compared to reading all the technical jargon in the system plan. But it is very detailed, it's very comprehensive, and covers a lot of ground. And so, how many of you went on the tour? I know we recently had the tour, right? A good number of you, right? And or been across the site before. So this will be a refresher for you, hopefully, but I wanted to just kind of re-ground everybody on what we have here today. So this is our overall graphic of all of our facilities and how they integrate. You can see they're very closely integrated, but kind of at a macro level, we have 43 remaining waste tanks that have not been closed. They hold about 32 million gallons of waste currently. A lot of that waste has been in there for decades. So literally it is dehydrated or dried up, whatever term you want to use, to it's literally almost in some of it is in a solid form. So we have to reconstitute that by adding water, liquids to redissolve that, mixing apparatus to get the stuff back into a fluid that we can get out of the tanks and process in our facilities. So that 32 million is going to become more like 70, 80 million in processing volume. The workhorse of our salt waste, of our processing is our salt waste processing facility here in the middle. Over 90% of that waste coming out of the tanks will be processed through that facility. That is, you may recall, our newest facility came online in 2021 time period, and it's a chemical separations plant basically, where the waste comes in, it goes through a series of filters and chemical separations processes, so we're able to separate out the bad materials from the waste, and then those go on over to the defense waste processing facility, where they get encapsulated in the glass and the vitrification process and poured into a stainless steel welded container. So they have double confinement, one within the glass structure itself, and secondly within the stainless steel containers. And then of course the final step is that liquid has now been freed of contaminants. It does go on over to our saltstone production facility, and basically it's a cement plant type arrangement where it gets produced into grout and goes into the salt disposal units. If you recall from the tour, that's a very large above ground structures. We're actually constructing the very last one, as Edwin described earlier. We're on STU 12 fabrication now, and well ahead of schedule. Those hold about 33 million gallons apiece. So we're going to give you a double shot this morning. So I'm going to tell you a little bit about what we're doing in the system plan. Brett's going to follow me. He's going to tell you a little bit about our cost and some of those kind of things. So you're going to get a full dose of liquid waste system this morning. Of course, our mission is to treat and safely dispose of these materials. So let me tell you about System Plan Rev 24. So System Plan Rev 24, periodically the system plan gets updated. The previous update was in March of 2023, so this version is about 3 years later. We actually approved it and issued it in January. And basically, it builds on the risk success of the work that's already been done. It talks about what's our mission status at the current time. It also talks about initiatives and technologies that we plan to bring to bear, and ultimately, what is our plan for completing this mission of emptying those 43 tanks and making them environmentally stable for the future. So that's a little bit about what the system plan offers. So let me tell you about some of the contents in it now. So from a risk reduction perspective, we're doing a very, very well. The graphic here on the right side of the screen, this is calendar year 22, if you can't see it from your seat. This is current calendar year 26. So if you look for the 8 years leading up to 2022, prior to contract change and kind of our latest strategy, you can see the astronomical increase in the amount of curies that are being processed. So actually, since 2022, in the last 4 years, we have processed 46 million curies. And curies is just, if you're not familiar with it, it's a measure of radioactivity. It's a way of measuring the risk, if you will, in the tanks. And that 46 million curies is about 20% of the inventory at this point. So as you can see here by the steep incline, with our strategy, we're going after the high hazard stuff first. That's kind of our approach in this contract and strategy, and we're being successful at it. So in the last 4 years, we've actually processed twice as many curies as the previous 8 years. So our pace of remediating is really stepped up, and we're going to continue that. In fact, some of the first tanks we're going after in this high-risk strategy is tanks that are at or near the water table, and we've only got one of those left, and we're on track to finish that, empty that tank later this year. So that will be one huge risk mitigated. And if you look over the next 3 years, in System Plan 24, we're actually going to cut the remaining curies by 1/3. So think about that. In 3 years, 1/3 of the remaining hazard is going to be gone or mitigated. So when people look at, is 2037 viable, 2041 viable, whatever date you want to challenge, I come back and point to this, that in the last 4 years, we've proven that we can process at a very enhanced rate. And our current plan says in the next 3 years, 1/3 of the remaining curies will be dispositioned. So again, so a 10, 12-year mission completion is very viable. So I think John mentioned the FFA earlier. Again, the Federal Facility Agreement is in simple terms, it's a multi-party agreement between the U.S. EPA, the South Carolina Department of Environmental Services, and the DOE that said, hey, for these, and specifically, it says for these 16 highest risk tanks, it lays out a commitment date to have those tanks emptied. We call that PCWR, preliminary cease waste removal. That means all the bulk waste has been removed from the tank, which essentially gets you about, the majority of the risk reduction, right? Once the tank's empty, it's just kind of sitting there, and eventually it's going to be filled up with grout or cement. But the big risk reduction is getting the tank emptied. And so over that same 4-year period I just showed you on the previous slide, we've actually emptied 8 tanks. 8 of those 43 tanks have now been emptied. We're on schedule to complete 2 more by the end of this calendar year, so that'll be 10 tanks in total. 10 of those 43 will be emptied by the end of December this year. And actually, if you look at our commitments over here for PCWRs, when we have completed the 10th tank, we will, by the end of 26, we'll have done all of our commitments through 2029. So we're about 3 years ahead of the regulatory commitment, which is where we want to stay. We want to stay well out in front of that. And then the other piece is once the tanks are emptied, right, the ultimate plan is you fill them up with grout, cement, and that stabilizes them for indefinite, period. And so we're working right now 3 tanks to be, 3 of those 8 tanks that we have emptied already are being worked for grouting. And 2 of those are on track to be grouted next year in 2027. A third one is actually right now, January, February of 2028. So actually by early 2028, we'll have 3 of those tanks grouted, totally closed, and that puts us a year or so ahead of our tank closure schedule as well. So from a measurement perspective, we're doing exceptionally well and want to keep that pace up. So that's a little bit about the risk reduction and the process we're making there. Again, all that's reflected in this system plan, Rev 24. So one of the second key pieces of the system plan is technical capabilities, right? So in order to complete this mission, we got to have the right technical capabilities. I want to highlight a couple of those that have really come to bear in the last 4 years, in that period where you've really seen that steep increase in risk mitigation. And a lot of that's contributed to a couple of things here. One is in our salt waste processing facility, the new facility that came online in 21, 22. It originally had 10-foot filters, and that was the original design. As with all things, as you put it up bring it from pilot scale up to full scale production, there's some learning that goes on. One of the things we learned in that plant, actually I was a director at SWPF at that time, prior to my current job. One of the things we learned is the pinch point in our process was the filtration. We could not filter was limiting our throughput. So our engineers went to work and they came up with, in the existing space we had, which is not huge, they were able to come up with a creative design that basically doubled the surface area of those filters. So we went from a 10-foot tall filter to a 16-foot filter. We added some more tubes on the inside and changed the insides a little bit. But the net effect of that is it doubled the capacity of those filters. So no longer is filtration our pinch point. In fact, we used to run, we have 3 of those filters and they can run in parallel. We used to run all 3 max loaded 80 PSI, maximum pressure we could put on them, and getting every drop we could out. Now we're able to run sometimes on just 1 filter at a very low pressure rating, and we're making equal or better progress, a lot better progress. So this was massively successful. Another thing that's really important that comes out here in System Plan Rev 24 is the volume of salt. I mentioned in the beginning that 32 million remaining gallons of salt has to be, some of it has to be redissolved, reconstituted to empty the tanks, et cetera. And it's going to equate to, a larger volume in the end. Well, we've gotten smarter and sharper on how we can concentrate some of this stuff, the chemistry of it. And so Rev 23 actually predicted 103 million gallons of salt to be processed to complete the mission. Through our innovation and better strategy now in Rev 24, we were able to reduce that down to 77 million. So if you think about that, that's about a 25% reduction in volume of salt. And as with any production line or plant, right, that's a major savings in cost and time. So I'll talk more about that on some of the future slides, but that's a huge advancement to our mission, not to have to process as much volume. A couple other technical things I want to show, and I'll get out of your way. I'm sorry, right in your way, aren't I? So you can see on the right-hand side, this is actually video inside an emptied clean tank. And I just want you to look at all the instructions in there. Those are cooling coils, various support structure beams, columns, et cetera. Okay, so up until recently, the way we had to inspect these tanks and get samples out of the bottom of the tank is we had to manually deploy, we call it a crawler. Basically, it's a robot on wheels, if you will. We would have to lower it down through one of the openings in the top of the tank. It would have to crawl around, try not to get hung up on all that mess. Of course, it had a tethered cord to it because it wasn't remote. It had a huge cable connected to it. So it was not uncommon on any tank that we would lose 3 or 4 of these over the course of emptying the tank because they would get hung up, we couldn't retrieve them, whatever the case may be. Those things cost $300,000 to $400,000 a piece. So you're talking about over $1 million a tank. Brett's going to talk more about cost, so I'm giving you some insight into that. So that was millions of dollars per tank just to inspect the tank, get the video we needed to prove it had been properly emptied, to see where we needed to further remediate, sample, et cetera. We have developed a drone program. We now fly drones inside these tanks. These tanks are about 1 million gallons, so they're pretty good sized tanks. So we can actually take a drone, a commercial drone. We got a special package that goes on it, you know, but drones are like $50,000 a piece. And so we put our special camera on there. We got some special sampling devices that we've developed and come up with to put on there. We can fly those drones right down that same hatchway, and this is video from the drone. It's way better. We can see the tank better. It gives us better intel into what we need to do to further clean the tank. At the end, it's much better verification on how clean the tank is. And you can see from that, that tank's pretty clean. And rarely do they get hung up. I think in the life, we've been doing drones for about 2 years now. I think we've lost 3. And we used to lose 3 per tank or more of the crawlers. And actually, we went for about a whole first year, we only lost 1. But we came up with a new sampling device recently to try to sample some of the hard pack samples, some stuff that had to have a drill to really get to it. And so in the learning of how to use that drill, we lost 2 more. But so the point being, it's been extremely effective. We get way better quality, way faster, way cheaper, and this is just another example of how we're able to advance things. Okay, so let me step back and tell you a little bit about the basis of the plan. So the system plan is not just, you know, Brett and I sitting in a room somewhere and kind of putting our wishes on a board. It has a very sound technical basis behind it. In fact, one of our partnering companies, DBD Incorporated, they're actually a UK firm, but they specialize, they're world-renowned, they specialize, one of the things they specialize in is simulation. And so we have contracted with them. They've developed a very sophisticated model that models every tank, every flow, every piece of chemistry in our entire liquid waste system across all of the plants. And of course, being a computer, what might take me months to do on a spreadsheet or manually, within minutes, it can run thousands of scenarios and and help you determine how to optimize that, the best approach, et cetera. So that's how we do our system planning now. We use that computer model, and we put inputs into it, and let it do its magic, and it runs thousands of iterations, and it comes back and it says, hey, the optimal way to do it is this. And we call this a DNA chart because it kind of looks like a DNA chart. But if you could see this up close, this is actually a layout from now, 2026 to 2037. And this is going down it this way. It's every tank of those 43 tanks that remain. And then across the timeline here, the different colors represent different parts, whether it's in waste removal, sampling, closure, et cetera. That's what's reflected. But you can see in the end, it generates this great pictorial, and it tells us exactly how many gallons of this we're going to need, what the timeline, when certain tanks can be closed, et cetera. And that is the technical basis for our system plan. Okay. So in Rev 24, diving a little bit more into the scenarios for Rev 24, of course we ran thousands of iterations, looking at thousands of things, trying to find the best case, the smartest way to approach this, the most economical, et cetera. And it really came down to 2 things that really were the drivers. One is funding, and the second one is technical capacity. And so we wanted to get bounding cases. We wanted to get what's the very best funding case, what's the very best technical case, And so we pretty much ran a case that was unconstrained funding. If we got, which is not terribly realistic to be honest, but it's but it kind of gives you a bound. If we were unfunded, if we were unconstrained funding, and we had all the funding we wanted or needed. Versus if a more realistic case, what if we're flat funded with some reasonable escalation every year, which is more typical, right? Every year, Congress has to appropriate funds for federal work. We're one of, thousands. And a more typical scenario is kind of current funding plus some reasonable escalation. Occasionally, you may get a little, some extra, but more realistic case is flat with some escalation. And then on the technical side, we put all of our smart people together and we said, what's the greatest things we could do? And let's assume all those things came to fruition. What technical capability would that give us? So that would be our maximum throughput case. And so we ran that case, And then we also ran, well, what are we consistently doing today? What rate are we consistently operating at, da, 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 da. So what does that look like? And so, again, we put all that into the model, it churned, ran millions of iterations, and it came up with what we have in Rev 24. And so let me tell you a little bit about that. So for Rev 24, basically what it concluded is that funding is the dominant thing. Thanks to the innovation over the last 4 years, and you saw that steep curve, now that we have salt waste processing facility online, we've learned how to concentrate the batches better, et cetera, all the technical advances we have, the really dominant thing is funding. And so if we get kind of steady funding, minimal flat funding, the end date looks somewhere around 2041. If we get more optimistic funding, the end date's around 2037. And technically, we can do that. And I tell you, as I showed one earlier, that's why I like to show that graphic as proof. Technical capability, we're pretty much there. We have the ability to execute. Now it's just a matter of being part of the annual funding cycle and staying the course with continuous implementation of innovation. And so if you think about it, the reason funding is a constraint. Think about your home budget, right? This is the way I like to think about it. At your home, you probably have you got to pay the electricity, you got to pay the water bill, you got to pay your home mortgage, you may have an auto loan. There's certain things that are kind of fixed, right? You got to pay those things. That's kind of the base load. And then on top of that, which for most of us, that consumes a fair amount of our income. Of course, we hope to have some savings in there too. But then on the top of that, there's this smaller amount that's kind of discretionary funding. That's so we can decide, how many times do we go out to eat this month, or how much I go play golf this month, or whatever the case may be, whatever you like to do. But that's kind of the discretionary funding. Where our budget kind of works the same way. Brett's going to delve more into that, but I'll tell you from a scenario perspective, it's the same way. You saw some of those big facilities. It takes a lot of money just to, quote, keep the lights on, to keep the equipment running, to keep them staffed, to keep the ventilation on, all the things it takes just to make them ready to serve, if you will. So that takes a huge quota of our funds. Of course, we don't want to go lay off people every year because the people that work in there, they have years of expertise. It takes years to qualify people. And so if we lose that capacity, we could, one bad year, if we had to go reduce a lot of staff in those facilities, could take us 2 or 3 or 4 years to recover. Because you got to go hire the people, which is a process. You got to get them in, you got to train them, et cetera. So we don't want to do that. The flywheel we have, just like you do usually in your budget at home, is that discretionary pot. And for us, that discretionary pot is typically the waste removal work. Remember I told you earlier, a lot of this waste has been in those tanks for decades. It's dried out, it's hard. So in order to get it out of there, we got to go buy pumps, we got to do a lot of physical modifications to run electricity to them, we got to get the pumps in the tanks, et cetera. All that's costly because these are not, pumps you run to Lowe's and get every Saturday. Some of these are $1 million plus pumps. Again, Brett's going to give you more insight on that. But these are costly pumps, and so if we do have fluctuations in budget, that's the part that usually gets adjusted most because that's just like your discretionary spending at home. That's the part that you have the most latitude to adjust. So what happens is, if you're not getting in the tanks and prepping the waste fast enough, you can have the greatest machine in the world, but you got to feed it, right? SWPF is a very, very capable of running a lot of gallons, but we got to be able to prepare feed in the tank for them and get it to SWPF at that pace. So if we do have restricted funding, it's going to restrict our ability to purchase, install those pumps, do the mixing, get the waste out, which in turn perturbates through the whole system. So that's kind of the downside of that. The upside is this new system plan told us 2 really positive things. As I already mentioned earlier, there's a huge reduction in the volume of salt because of the way we're able to process salt today. It goes down from 103 to 77 million roughly. That's about a 25% reduction. So that means the salt waste processing facility no longer needs to operate at 9 million gallons per year. I'm going to show you some numbers here in a minute, but leading up to Rev 24, that had kind of been the mantra that we needed the salt waste processing facility to get up and online, and it needed to process 9+ million a year to get us there. Well, that's no longer the case. The second thing is we had also had a vision of implementing next generation solvent, which is just a more sophisticated solvent. than what we currently use in our solid waste processing facility. And actually, this analysis showed us that we really don't need that to achieve the mission. I'm going to pause there. That's a lot. And I'm rattling through it kind of quickly. I'll just pause here for any questions so far. Yeah. Yes, sir. Yes, sir. Yes, sir.
Can you turn your mic back on, Matt? Can you turn your mic back on?
I thought I did. First of all, I enjoy listening to you because I love somebody who loves their work.
Yeah, thank you.
And I got a bunch of questions though. At the
Yes, sir.
separation facility,
Yes.
is it possible to remove the uranium, say, to 20% or the plutonium to 20%?
We were actually in our separation facility, we removed the uranium and the plutonium down to fractions of a percent. I won't say to undetectable, but it's well below, you know.
No, I understand because y'all classification,
Right.
take that out.
Right.
But I'm wondering if y'all could combine it and say, take the uranium up to 20%.
So, are you talking about like some kind of blend down strategy? I'm trying to follow your question. So basically, well, let me just, so in our chemical separation, right, we take the waste out of the tank. It first of all goes through a chemical strike and a filtration. And that chemical strike actually bonds with, when we add the chemicals, it bonds with plutonium, uranium, and actinides, things like plutonium, uranium, right? And they become solids. So when that material passes through the filter, the plutonium and uranium is left behind in those solids. So the liquid passes on over, and then those solids are what we send over to DWPF, and they vitrify. So we do remove, 99+% of it.
No, I'm just looking at the future because it looks like the, 20% uranium.
Oh yeah, with like the HALEU and some of those things. That's what I'm trying to understand your question.
I think he's talking recovery,
Yeah.
and not the.
Oh, recovery, no. No.
Yeah.
The Canyon is in the recovery business, and that used to be my business, so I know a little bit about that too. But we're in the waste disposition and disposal business. But it is similar technology, right? So in the Canyons, likewise, they have chemical separation where they do the same thing. But instead of recovering uranium to solids to go to waste, they recover it into a usable form that can be used for other things.
No.
Yeah, I'm just looking at the money in the future and the way this country's going.
Yeah. So
Edwin,
could the facility be retrofitted for that? I wouldn't say anything's impossible. Right.
Did you want to expand on that, Edwin?
Yes. There we go. Yeah, great question, Mr. Kilroy. Great engineering mind. So he's absolutely right. In the past, what we would do, we had, we sent all waste to the liquid waste program, and they would strip it out. So as you know, under the new administration and new boss, Mr. Walsh, we pivoted on H Canyon, so we're no longer doing accelerated basin de-inventory and sending stuff to the tank farms. What we're going to do is revitalize H Canyon to recover the uranium, to make the HALEU and the percentages you're talking about, and they would be blended for a vendor to be able to use in small modular reactors, those kind of things. So absolutely right. So we're not sending that stuff to the tank farms anymore. We're going to recover it, and then future missions include HB line, where we're going to recapture plutonium. And so, but yeah, we're pivoting and going the other direction, and these are valuable assets in these waste streams. And so we're
unbelievable.
That's correct.
Yeah,
Correct.
yeah.
So we definitely are going to capitalize on that.
You're going to see that in a later slide of mine too,
Okay.
the impact of what Edwin just talked about. Yes, sir.
So I hope that answered that question for yourselves. Excellent.
Another question?
Yeah, I do. The increased concentration of the salt
Yes.
that y'all using, how does this affect leaching?
It doesn't. The end product is the same. It's just we were able to process it through SWPF at a higher sodium molarity. So basically the waste used to have to be more dilute. We thought we'd have to run it at lower sodium molarities to get the separation that we need. But we've proven that we don't have to decrease the sodium molarity that much. So effectively, you got less dilution in it, so we're able to reduce the volume, and we're getting the same output.
And so leaching is the same then?
The same, yes.
All right.
Let's move over to Willie.
Willie Priester, Cap. Question for you. You mentioned earlier, thanks for your presentation, it's very good. Related to the innovations with, of course, the filters.
Yes, sir.
As well as the drones. Both of those things seemingly have made things a lot more efficient with the processing.
Correct.
Are there other processes that's being considered that would improve it even more and keep it safe as well as efficient?
Yeah, absolutely. I just highlighted 4 here, but in the full system plan, there's 3 or 4 times that many, right? I just highlighted some of the bigger ones.
Okay.
And so the beauty of it is, you know, I didn't cover the numbers, I don't think, on those slides, but each of those has a cost savings associated with it, right? And so we take that money and dial it right back into the mission, right? So every dollar we save is a dollar that lets us go after another tank, right? And so it's a, you know, we're almost like a nonprofit in that regard, right? Every dollar we save is a dollar we can put right back into the mission, and that's what we do, because that's what the department has incentivized us to do is, you know, mitigate these tanks as soon as we can, with the funds, and of course safely. Yeah. Mm-hmm.
All right, and we'll come across the table to James.
Thank you, Mr. Hall. That was very enlightening. I just wanted to get a little clarification on some of the terminology used around the financial funding part of it.
Yes, sir.
When you say flat/constrained, is constrained meaning actually going down, or is that the same as flat?
In this case, it is not going down. It's not what we assumed. We assumed, I guess, unconstrained being, you know, if we had unlimited funds, right?
Seems like
and
those are the more optimistic.
Exactly. You got the message exactly, right?
Okay.
We ran kind of the bounding case. What if we had infinite money? You know, if I had infinite money in my house, I might do different projects than I do, right? But I got a budget to work within, so I have to adjust my project to fit my budget, right? Same deal with us. But probably the more realistic scenario, and again, no one can predict year to year, you know, what other competing parties are across the nation. But in general, if you kind of look at history, a reasonable assumption is kind of consistent funding with a little bit of escalation or growth, you know, to account for inflation.
It's never really gone down. We've always had at least.
Yeah, historically it's pretty flat with some escalation, right? Of course, I'm not saying there's not one-off years. Yeah.
Stuff now, you don't expect anything like that?
No, we're not. In fact, we think we have very strong, the department is very strong supporter, Congress has been a strong supporter, so, you know, again, I can't predict this with absolute certainty, but you know, best case probably is our funding stays in that realm.
Okay, I got a couple of follow-ups.
Yeah.
So it looks like, from a technical perspective, you've got all the problems solved already. All you need is the money to implement them. Is that correct?
Yes, sir.
That right? And then out of those costs, it sounded like pumps were a big part of it, and then also solvent. And I remember from the tour that salt that you use for solvent is super expensive. Are those, and where does labor come into it? What are your biggest areas in that budget that you have to worry about?
Yeah, like most places, you know, labor accounts for, let's say, roughly 75% of our cost, right? And that's pretty typical for any. That's the biggest, right?
Okay.
And as I mentioned earlier, we have a very knowledgeable, trained workforce. So obviously, we don't want to lose that. We want to sustain that. And just like any company, we have normal attrition. You know, we have retirements. People leave for other opportunities to some smaller degree. But so we have staffing plans where we try to stay in front of that, you know, do periodic hiring and training so that we're always staffed to meet the mission. But yeah, labor is a good portion of ours, which is not atypical. And then the funds for the other things, like the funds for the solvent and the equipment, all that is part of our budget, right? So when we budget annually, we budget in, and that is all baked into this plan. So with this plan, if we get the funding that we anticipate, this plan will be successful. And don't get me wrong, this is not they're saying we're in a desperate funding scenario. I'm just trying to help you understand that we look at bounding conditions, right? We look at the most optimistic case, which is probably not realistic, but it gives you a bounding capable, you know, with the what if, what could it be, and then we look at the more, you know, what is the more realistic, I wouldn't say pessimistic, but realistic bounding bottom case. So we know we're somewhere in between there.
And you answered all the budget and the technical stuff, but I just have one kind of follow-up on what Mr. Deshawn touched on with this pivot about retaining the plutonium and reusing it in different facilities. What does that do to your budget? Is that already incorporated in the plans? And then what about storage for that stuff?
You're a great lead-in. So if you'll let me, I've got a slide later on that's going to cover that exact topic. I want to answer it for you if that's okay. Okay. If I don't answer then, hit me up again.
We'll come back over here to Deborah.
Okay, I was listening that you was stating that it takes years to qualify the people.
Yes.
And then looking at your, the drones and giving us an update on that, and also confirming, looking at your higher production rate on the graph, how the production rate is going up to allow you to do your job.
Yes.
So looking at those FYI years and going up, the funding that has been coming in is excellent based on you are ahead of your schedule. So just wanted to look at that part about years to qualify the people. Technology has also came an awesome opportunity part of that.
Absolutely, and so we're continuing looking at that. And in fact, I would say, you know, we're looking heavily into AI and how we can use the latest technologies and things to help us in all parts of our business, whether it be engineering, staffing, whatever, training. You know, we're beginning to deploy AI into our training programs to help us expedite things, et cetera. But fundamentally, right, people come in, at the bottom line, you got to have some number of people. And those people come in, and there's a minimum amount of training we need to make sure that they're of nuclear standards and meet the regulations to operate our facilities. We're always looking for ways to streamline that and make it better, and we've made a good bit of progress in that. But that is there's a timeline to that. Yeah. Okay.
All right, thank you.
Okay, thank you. Okay, a few more slides. I'm going to wrap up, and I'll take another round of questions. But I won't bore you with all the numbers here. These are some of the stats right out of the system plan. Again, if you want to go read that QR code, you can read this in great detail. But just to highlight a couple things here. Of course, this middle is the 2041 finish case, which is kind of the flat, minimal escalation, case. And then over here on the right is a case that says, hey, if we get very optimal funding, 2037 is very viable. A couple things to note here, as I mentioned earlier, up until Rev 24, we had kind of been locked into the idea that we had to get 9 million gallons per year out of SWPF. And you can see in Rev 24, that actually dropped down to more like 8 million. So the maximum throughput requirements are in FY30 in both cases, and it's just shy of 8 million gallons per year. But if you look at the annual average across all the years, you see it's about 7 million per year in the 2037 case and about 6 million in the 2041 case. So clearly the demand on SWPF is less than we had projected in previous years, and that's because of the reduction in the salt volume. And similar down here at DWPF with the glass vitrification, you see, the max can years are in the high 200s, early 300s, and that is, we've had years in the past where we operated greater than 329, so that's very achievable with a reliable plant. Of course, the average numbers per year, you see 163 and 247. So I just shared this not to bore you with a bunch of numbers, just to say that there's some positive in here. The demand on the system is less to actually accomplish it in the time period we want to than we had previously predicted, thankfully because of technical innovation. And these numbers are, we're proving every day they're very achievable. And so if you look at System Plan 23 overall versus System Plan 24, the new version, I would say we flipped the tide a little bit. The 2030, the Rev 23 version, the previous version from year 2023, it had a lot of technical risk in there. I mean, it had high expectations for getting this mission done, but there were a lot of unanswered technical questions. In the last 3 years, we've answered a lot of those technical questions, and that's why we've been able to really ramp up the throughput. So I would say Rev 24 almost turns the tide in that a lot of the technical questions are answered. There's not nearly the amount of technical risk. Now it's just more, hey, we just need to be steady. We need steady funding to stay on track, and our goals are very achievable. And as I mentioned earlier, this plan actually gives, like many projects do, it gives an early finish and a late finish. And so the early finish right now is 2037. That's based on optimal funding, good technology, continued technology investment. And then kind of a worst case, a bounding case on the high end would be a 2041 finish. The good news is in both of these cases, if you go back and look at that DNA chart, we satisfy all of our FFA commitments. We stay on track with all those, which again is the most important thing, is that we're reducing the risk. And then, you know, as I said earlier, we're incentivized as a contractor to move towards 2037, regardless of what the funding is, regardless of what the challenges are. That's what we're incentivized to do. We got a good contract structure with the government, and you know, we strive every day to do that. This is just a plot right out of the system plan that shows the different markings here. Now, these are the FFA commitments, and these are, in the shades of blue, are the actual dates we predict completing them. And you can see in all cases, both, in all cases, we satisfy the FFA commitments. So where are we today? So I would say in the last 3 years, we've addressed a lot of those technical uncertainties, and we have much higher technical capability and confidence in that. So now it's all about making the system run, right? The system's got to operate. You can have the greatest system in the world, but it's got to operate to make hay. And so we're really focused right now on availability. And we have this campaign, we call it Drive to 65, because in the system plan, all those models, it said that in order to hit the milestones that I talked about on the previous page, we need to average 65% or better plant availability. In other words, the plants need to operate 65% of the time or better. And you know, most plants, industrial plants, you know, run in the 60 to 80% range. All plants have to have downtime for maintenance and, you know, overhauls, those kind of things. But it does vary some from industry to industry and plant to plant. We're striving to do 65% or better. We've got a list of initiatives that we're working. Most of these things are around overhauling aged equipment, making sure we got adequate spares on hand so that if something fails, we aren't down, you know, for weeks to make an in-plant repair. We can simply swap it out and then go make the repair offline. All those kind of things keep the plants running, which keeps the mission moving. So we've got about $200 million actually between now and 2031 of infrastructure improvements laid out that will vastly improve our availability. And actually you can see here, we're actually tracking above 65 now. We're in the low 70s right now. So we're doing well there. We want to continue to build on that. Of course, we still do have the two risks. I've kind of hit on both of these. You know, one is aging infrastructure. You know, our facility started in the early 1950s, and so we do have, you know, tanks and other things that go back to the early 1950s, so they're 75 years old. So keeping in front of that from an infrastructure capability is always a challenge. And of course, as I've talked about now a lot of times, I mean, funding, we just want to make sure we're consistent and steady, don't have any significantly down years, and our plans are very viable. So you asked earlier about, a couple of you asked about the uranium recovery in H Canyon. So in the original System Plan 24 that came out in January, it had two opportunities, it had multiple opportunities, but two of them were that there could be a change in direction and the canyon could go back to recovery of uranium in lieu of disposition to us in liquid waste, and that has come to fruition, as Edwin just described earlier, or a couple times described earlier. And the second one is, of course, as that early graphic I showed, all of our plants are closely integrated, right? So if there's an upset in one plant, it disrupts the flow of material to the downstream plants, et cetera. And so anything we can do to put buffers between those plants, whether it be extra tank space, et cetera, it allows us to take, you know, if there's a small maintenance problem in one facility, it doesn't perturbate the whole system, right? The other plants can keep running till that plant gets back online, and then we can make it up or whatever. And so one of the great new ideas we have is further decoupling of the salt waste processing facility from the defense waste processing facility. Basically, we're going to, instead of sending batch by batch those high waste materials over to DWPF, we're going to collect them in a big collection tank where they can be sampled one time, characterized one time, and sent over in a more consistent manner. And that's going to help our processing in DWPF and allow it to process better. So the net effect of that is, and this table's right out of our system plan. So we issued Rev 24.1. We're trying to get like Microsoft. We got .1s now. But so 24.1 came out a month or two ago. And basically it recognized the change in direction with H Canyon going back to uranium recovery. And if you look at the impact of that over the life of this mission, it's going to cut out about 150 canisters we need to produce at DWPF, because now that material, instead of being vitrified, is going to be put to, you know, purposeful reuse And then our initiative to further decouple DWPF from SWPF is going to reduce about another 150 cans. So the net effect is about 300 cans. So our can count has gone down, which, if you remember back to the earlier slide, 300 cans is about 1 year of production. So basically that cuts a year of production off of DWPF, which is huge, right? So that's a big deal. And cost savings and ability to take those funds now and reinvest them back into emptying tanks or whatever the case may be. All right. So in summary, the technical barriers that previously existed, System Plan 23 and before, we feel very good about that. We've made good progress in overcoming many of those. The systems are operating well as a result of that. System Plan 24 gives us a very high confidence case of 2041 and a very realistic case that would, reasonable, consistent funding and continued technical innovation. 2037 is still very viable, and that's what we're driving to. In all cases, we plan to stay in compliance with our regulatory commitments, the FFA specifically. And of course, we have a really good working relationship with the department, and they strongly are incentivizing us to move forward with this mission, and that's what we're trying to do. All right.
Before we start going through questions,
A couple of notes that I want to make real quick. One is that I know that there's some interest in isotope recovery itself. Let's keep in mind that that's through the H Canyon facility that's operated by RMNO, SRS. This presentation is about the liquid waste program. That's the waste material that comes out of the canyon on the backside. So it's not that we can't have the recovery conversation, but maybe not right now. That's not what these slides are about. So let's make sure that we stay on the liquid waste side of the conversation. The other thing that I want to note before I move to James for our first question is make sure you're talking directly into the microphone so that it picks up, not just for the folks online, but so that when Stephanie does the minutes, I don't let her put down cab member mumbled to self. And I will let her put that down if we can't hear you. I'm not going to make her work for it, okay? So don't make her work for it. All right. We clear on those two things? All right. James.
All right, and I won't go into the defense part of it, but it sounds like it does improve your budget, but it doesn't mysteriously mitigate the cost. So it just gets transferred to another department. Will we be talking about that today in another presentation?
not today, but
Okay.
we will at a different.
It'll be on an agenda in the future. Okay. That's all I have.
All right. Pat.
Pat Kilroy, Cab. Two quick questions. Up to this point, I thought the solvent used in these things was water.
No, sir. It's an organic mixture of a mixture of organics, right?
It's a mixture of organics?
Yes.
Okay.
There's a special recipe to it, right?
Okay. And this may not fall under you, but I wonder, and I know that the actinides are the heaviest there in the bottom of the tanks. And so when y'all empty them, everything, what happens to the old tanks?
What happens to the old tanks?
Yes.
Okay, so of course the 43 waste tanks we're trying to empty, once they're emptied, and you saw video of one that had been emptied, they're emptied pretty well. Then eventually those tanks get filled with grout, with cement basically. And it's a special formulated cement that's been tested through the National Lab and other technical authorities to show that it will, maintain consistency and be bounding for millions of years, basically.
Eons and eons,
yeah, right, yeah.
Okay, thank you.
Yeah. Okay.
All right. James, did you have any more follow-ups? Nope, I got to ask. It's okay. Any other questions from around the table? Seeing none. Steve, thank you so much. I appreciate it. All right, we're at 10:18. Our next presenter is mic'd up, but I'm going to ask, do we need to take 15 or do we want to keep rolling? We're definitely going to take a break after him if we keep going. But if y'all need to break now, we can. How do y'all feel? Keep going? Everybody want to nod at keep going? Do we need a break? No one's willing to say it? All right, I'll tell you what. Let's take about 15 minutes. It's 10:18 now. Let's say 10:30-ish, okay?
Where are we going?
All right. I am saying that I have a very strong-willed 5-year-old who has what he wants to do, and then there's what he needs to do, and there are two different, there's usually a delta between the two. I got older kids, I know. Yes, yeah. Oh, my daughter is my retirement plan. She's our rock star, for sure. All right, anyway, let's get started. Let's bring it back in. One thing I wanted to note before we got going. Did everybody catch the very beginning of Steve's presentation? Do you remember what he said? It stuck with me. It's one of my favorite openings that some people have. I live here. My kids live here. My grandparents, our grandkids live here. The folks who work at Savannah Riverside have vested personal interests in the safe operation of the site. They don't just work there. We live in this area. Our tap water is the same as yours. We have to care because it impacts us just as much as it impacts you. Coming up next, I hope you really like math, because if you don't, you might get lost here just a little bit. But Brett's going to break it down for us.
Hey, Brett Evans, hi, nice to meet everybody. This is the first time I have presented CAB, so looking forward to it, and I'm glad to answer your question. I promise the math is not going to be that hard. If I start talking about accounting too much, if somebody will take a piece of candy and throw it at me, I would appreciate it. But I look forward to speaking to everybody, and if you have any questions, let me know.
That was bad too.
I broke the first one.
James, can we get another family
You know, you ever have a 5-year-old look at you and say, I don't think I would like to do that, and pronounce every word? Okay. It's unsettling.
Broke the second one. I'll speak loud.
No, we won't be able to do that. We've got, here, let me play. Oh, he's got another one.
Try this one.
If not, we'll steal mine.
All right, again, my name is Brett Evans. I am the Chief Administrative Officer. So I've made 4 different trips to Savannah River. I started in '90 and have been out there 4 different times. So they keep asking me to come back, and I like coming back every time. So it is a great place to work, and to kind of follow along with what Steve said, every time I get a chance to talk to anybody in the community, interns or anybody, I tell them, this will be the most important job you will ever have. And I really believe that. The work that we're trying to do is important, it's critical, it's to try to have, be safe in the community. My grandkids live here, my daughters live here, so it's important to me. So it's just the way we work. Let's see. So I'm gonna give you a little rundown of kind of what the contract is. We'll talk about the cost, where we spend our money, how expensive things are. We'll also look at what the price. Those are brand new buildings. I got the touch.
Mm-hmm.
I'll try that.
Electricity must be going on.
How about that?
Yes.
All right. So I'll talking about I'll change the subject real quick, but we were talking about the repository for glass. So I was the last CFO on Yucca Mountain. So I was out there for 2 years, and when we went out, we thought, man, this is gonna be this is where it's gonna happen. And we got about a year into the project and that deal. So I was out there when we won it. Everybody was excited. We were getting ready to go to work, and then we killed it, and we spent the next year and a half, 2 years bringing it back again. And there was a lot of money spent. There was a laydown yard out there of about 40 acres that had nothing but yellow iron in it. It was ready to go to work. So we just abandoned it and walked off. So that's where the repository is now. But back to our contract. So these are the players in our contract: Momentum, BWXT, and Fluor. We also have 2 integrated subcontractors, and that's DVD and Westworks. They're also our mentor protege contractors too. We usually have between 2 and 4 mentor proteges, and they're typically small contractors, and we're trying to help them establish themselves. And these are the 2 that we've named in our contract. Right now, we're at about 3,500 people. About 600 of that is craft, and then you've got non-exempt, exempt, some LSCs, and some others. So that's about where we stand, and that's pretty level. We have maintained about 3,500 people since we started the contract back in February of 2022. So this contract, it's a cost reimbursable contract, but it's called an in-state contract. And that's a little unique in the DOE world. So as Steve was talking about, every dollar we save, it doesn't matter where it's at, we try to put it back into the program, back into the work that we're trying to get done. So every indirect dollar we save, we put it back into direct work. So that's really the focus of what we're trying to do. So when we find ways to do things better, cheaper, faster, all of that money that we save, we put right back into the program. So that helps us maintain the levels of production, keep our hiring where it's at, maintain the workforce benefits, and that's what we use to move the program along. So currently we've got task orders 5, 6, 7, and then we've got some small ones, and those are 10, 11, and 12. Task orders 5 is the SDUs, and like Steve was talking about, we have just started the last one. And then our primary operations are task order 6 and task order 7. And that's where most of our money gets spent. The 3 small task orders, very small, and we'll finish those up in the next year. If you notice, there is a gap between 7, so task orders 8 and 9, those will be the extensions to our contract when we get to that point. We got a 10-year base contract, and then there's a 5-year option on the back end. All right, so when you hear cost, our cost is direct and indirect. So a direct cost will be anything that's working in solid waste processing, DWPF, so any of the direct work will be a direct cost for us. Indirect cost is going to be the folks like me, like Steve. I'm in program support. That's human resources, accounting, all of the things that payroll, all the things that support the operations and support the direct work, the direct employees. It's really G&A, as some people call it, but it's an overhead for us, and we allocate that overhead over all of our direct work. One of the biggest costs we have is naturally our labor. Employees make up about 75 to 80% of our cost. The fringe benefits are another place that's expensive. As everybody knows, your medical expenses go up every year, it does not go down, and we experience the same thing. We try to shop as much as we can to try to find things that are cheaper from a benefit standpoint, but you got to draw the line at some point because you don't want to start hurting your employees. So we spend a lot of time trying to find the best, cheapest way to do work in program support because we really want to try to save the dollar. All right, now this is where the accounting, so don't let me get too far into this, but we have different types of labor, exempt, non-exempt, and craft. And exempt is, if it's, as my grandfather used to say, it's from can to can. You may work 60 hours, but you get paid for 40. So that's what an exempt is. A non-exempt, you get paid for every hour that you work. And then craft are the same way. We have a project labor agreement with all of our construction craft, and we follow that. We pay them according to that labor agreement. We have a lot of subcontractors. Staff aug is a lot of the things that we use out there. We do not have all of the perfect resources, so sometimes we have to go find resources. We have a lot of different staff aug contractors that we depend on. We call on them. A lot of times we try to limit that to short periods of work, specialized work, but we do call on them as work and support what we're trying to do. We also buy services from the M&O contractor and BSRA. We've done that since the start of the contract. SRR, the Savannah River Remediation contract that was before SRMC, we did the same thing there. I was a CFO, so we've been buying services from the M&O since the two contractors split in 2009 and 10. And a lot of the services, payroll and benefits accounting is one. We have a really small payroll and accounting function, probably a third of what most companies have our size. A lot of it is we worked with our IT people and created a lot of applications and support functions and feed what we're trying to do. And some of that is through SRS. So it's been a good relationship. They know us, we know them. I worked with a lot of them when I was out here under the WSRC, so it's a relationship that we work well together. If we got a problem, we typically can call on them and they'll try to do what they can to get us to the head of the pack, but it is a relationship that we really depend on. The other thing that we have is direct material and travel expenses. So direct material will be anything that we buy that supports the function that the direct work is. So if we're buying a pump and solid waste processing, or we're buying additional canisters for DWPF, that's all direct materials that we buy. It also includes furniture, training materials, engineered materials, so a lot of specialized equipment that we have to buy. Like Steve said, we don't buy a whole lot from Lowe's. So anything we buy typically is going to be from a select vendor. A lot of times it may be a sole source. It's the only vendor that can manufacture or build the part we need. One of the issues that we're running into, and so the rest of the nuclear world, the same thing. About 40% of the vendors that have supported nuclear work over the years are out of business. A lot of them were small businesses. They've been bought up. Some of the larger businesses have gone out of work. So it gets harder and harder for us to find some of the things that we're looking for. We're using AI as an example to try to help us go find a larger vendor pool. We're trying to be as creative we can, and vendors are going to be critical for us, our success. And NNSA, as they move forward with the PIT facility, they're going to have the same issues with vendors. And then our travel expenses, that's one of the things that we get audited every year. We've got an internal auditor that works for us. We also have the DCA, which is the audit agency that we use, and they always look at our travel expenses. It's not a lot of money, but that typically is going to be where, somebody got a rental car, they accepted the insurance. Well, we don't allow you to accept the insurance. So those are the kind of things that we're always looking to try to clean up from a travel expense point. Not a lot of money, but it's a lot of effort to go do that. All right, so for us, cost accounting standards, that's kind of the Bible. We have to be in compliance with that. That's how we pay the bills. That's how we pay the stuff that Steve was describing a little earlier. It's prescribed. We have a disclosure statement that we have to follow. And it basically, it explains to who's charging their time, who's charging for a piece of equipment, where they charge, how they charge, how the overheads are allocated. So all of our costs and expenses are laid out in our disclosure statement. And it truly is how we are going to do the work, how we're going to account for it, how we're going to invoice the customer, what the customer is going to see. So it's the Bible for us. We have to submit one every time there's a change. The customer sees that. A lot of times it'll even be sent to the audit agency, depending on the magnitude of the change. But it is the lifeline for how we do our work. As long as you can stay within the bounds of the disclosure statement, you are less likely to be audited. It makes invoicing, as a matter of fact, to the customer much easier. We have worked with the same accounting folks over in DOE for years, so our invoice process has really gotten down to a science. And because they depend on us to follow the disclosure statement, the amount of oversight that they provide is nowhere near what you would see at some of the other DOE sites. We have, typically we'll have some of the others come out and take a look at how we are doing our business, just to see what makes us different from everybody else. And I explain to them every time, it's because we are transparent. We do not keep anything from our customer. As soon as we see that there's an issue with a charge or something, we go straight to the customer and say, look, this is what's happening. And this is what we're going to do to correct that. We'll correct the next invoice, and I think that transparency has made a difference over the years. It certainly has reduced the amount of oversight that they have to provide, and the customer sees our entire general ledger, which is somewhere around 100,000 lines. So they can see every cent we spend. Every month they can see every cent. So we know that, so we make sure that what we send them is correct every time. Our timekeeping system is cost point. We are a total time accounting shop, and that means that you account for every second that you're doing work out there. So if you work 10 hours in a day and you work 6 minutes, 12 minutes over, then you're gonna show those 6 to 12 minutes in additional time. We want to know exactly what it takes to do the work out there. A lot of companies, just if you're exempt, you charge 40 hours. What we want to know is how many hours it takes to do the work out there. You're not getting paid for it, but we want to know exactly how many hours it takes to run this shop, to keep the plant going. And this is a 24/7, we never shut down. And that's one of the things that you can't stress enough to people. Everybody else gets to go home when there's an ice storm or gets to go home in a hurricane. We do not get to go home. Our folks are going to be out there. We make space available for them. And if you are in the critical group that has to be out there, and it's about 300, 400 people, you are going to camp out there. We'll make space for you to sleep, and we'll get food to you, but you're not going to come home. So that's how critical it is to keep these plants going. You can't walk away from these places. So this is a little bit of the funding, and it'll show you kind of how things are broken out. So I've got two charts here. The one on the left is looking at it by task order. And you'll see that our total funding, our total cost for this year is almost $1.2 billion. About 176 million of that is cost that some of that is DOE cost. It's for pension payments. Some of the DOE overheads, things like that, are in that. But then you can see the other costs by the various task orders. So if you look, you can see that task orders 5 and 6 are 6, task order 6 for tank farms, defense waste processing, solid waste processing, in-stream delivery. That's the majority of our work. Task order 5 is a capital line item project, so that's a different funding stream for us. But you can see that's the majority of it. And then you can see that same cut on this side, and it shows the labor, craft, direct labor, staff logs, material service level agreements. So it just shows a different cut by the cost element for the same cost that we have by task order. That make sense? All right, this is some cost trending, and if you look at the columns, you can see that the colors don't change a whole lot. Our funding and the costs that we generate, it's pretty constant. Occasionally you'll see an accounting change, which is what's driving the service level agreement cost difference here. But by and large, I mean, our labor is pretty stable. Really the things that we have to look at, the ebbing and flowing part of it for us is going to be materials, subcontracts, things like that. But the labor charges for us are pretty constant. We did talk about funding some. Steve was discussing that. You know, even if our funding stays flat, your buying power goes down every year. So if inflation is 4 or 5%, then you can imagine if you're holding that $1 billion is what you've got in funding over the course of 3 or 4 or 5 years, you do not have $1 billion to spend. Our salaries go up, benefit costs go up, material goes up, paper towels, water, toilet paper, it doesn't matter what it is. We buy it in such large quantities, there is a cost increase every year. And we are always trying to figure out ways to absorb that and continue at the same level we have in the program. So it can be a challenge at times, but you'll see the cost for the last 2 years, actual cost for 24 and 25, and then you've got the cost that we're expecting for 26. So for us, when you see FY, that's fiscal year. Fiscal year for us is from October to September. That's the same fiscal year that the government operates under. Some companies are a calendar year, but we happen to be on a fiscal year. All right, how much do things cost? And this is a question I get asked all the time. I don't ask my wife that when she goes and buys something at Amazon, but everybody asks me about this. So for us, cleaning a tank out, as Steve was talking about, so that's preliminary cease waste removal, PCWRs, and it's about $23 million per tank. So it's not cheap. But when you look at that, that's not 1 year's worth of work. That's many years worth of work. You know, you don't just go in and clean a tank out in a year. That has been going on for years, all the work and effort they have to do to get the tank tops ready to go, all the risers that they have to work on. So there is a tremendous amount of work and man hours to try to do that on one of those tanks. To operationally close the tank, and that's to grout the tank. That's to remove a lot of the equipment, things on top of the tank, disconnect it from power, all of those things. It's about $15 million. I think to grout a tank, it's like 10,000. I think 10,000 trips from a concrete truck that it takes to fill one up. So it's once we start filling one up, we don't stop. So it's a continual operation, and it's $15 million worth of work. I mean, that is a tremendous amount of grout. I just got through building a driveway, and where I'd been paying $215 a cubic yard, it's up almost $500 a cubic yard now. And we pay more than that for what we use because it's a specialized grout, specialized formula. It's got chemicals in it, so it's not like pouring your driveway. And then you look at some of the other items, agitator assembly, the crossflow filters that Steve was talking about, pumps, $3 million, contactors. Here's the tank crawlers. I mean, they're $500,000 for a crawler. So you can pay $500,000 for one of those, or you can pay $30,000 for a drone. So it's a pretty simple math there. We can lose a lot of drones before we pay for a crawler. We are looking at a lot of different robotics, which we're just now getting into and pricing. I think everybody's probably seen the dog-looking one. We've got one of those that we'll use when we go into high rad rates or high rad areas. We've got a crawler that we'll be able to use on the bottom of the tanks, but it's untethered. So instead of it getting hung up in the mile of coolant pipes in the tank, it'll be able to move around within that, and we'll be able to get it back out, hopefully. But right now, the biggest win it really is the drones. I mean, that has been spectacular out there. We've even opened up an off-site facility that we can use for the drones as well as 3D printing. So that'll speed up our drone usage and the 3D printing. You have some restrictions on flying drones on site. But once you get outside the fence, you don't have those restrictions. And then you've got commercial submersible mixing pumps. And we try to use commercial where we can. In fact, we're trying to be more commercial every day, quicker, faster. I mean, it's the way to go. But there are limitations on that. It is really hard to find vendors, but we are doing a lot of things to shorten the vendor cycle or the acquisition cycle. Our terms and conditions at one time was almost 80 pages. We had some terms in there that a lot of small businesses would shy away from. So that's one of the things we're doing is cleaning that out. We have used AI and cut that down to about a little over 20 pages. But we're using AI, and that's one of the things that's going to save us money. We had a procedure that was about 126 pages. We turned AI loose on it, and I think it was 18 pages when they got done. So to just tell you how important that's going to be for us in the future. It's certainly for things that are redundant that we do day after day, it can be a real time saver for us. So the big thing that we're focused on, like we've talked about, Steve, as well, is really we are trying to save every dollar we can in areas that are not affecting the program. If we can save $1 in the president's office, we will. If we can save $1 in HR, we will. I mean, we are looking for ways to save money, put it back into direct work, put it back into hiring people that'll be doing direct work, craft operators, maintenance people, whatever it is. That's where we can really benefit the most. And the quicker we can get done, the cheaper it's going to be for the taxpayer, cheaper for DOE, and I think we all want that. Again, AI is something that we're working on. The cost savings in drones, we're using laboratories. In the past, we used SRNL or BSRA. We use those labs. We still do. But there's a lot of lab work that we can now take off site. So it's gone from 6 months to a matter of weeks. So that's part of what is the cost reductions in PCWRs, all the characterization work we have to do. I mean, the quicker we can get that done, the quicker we can get it turned back, the quicker we can move on to the next tank. We are also looking at if we can figure out a way to do it cheaper. If we have the ability to go off site, we will take that ability every time. If we can find a cheaper option than the processes or solutions that the M&O offers, we will certainly take advantage of that. It's an area where we've identified some savings opportunities, and we're still looking at those. But there are cheaper ways to do things, and if we can, that's what we're going to try to do. So that's really what this self-perform is all about. We're looking at it from how to do payroll. Is it cheaper to do something different than we do today? So I mean, we are looking at all the options that we have to reduce the cost for what we do out there. And then we also look at, let's look at a graded approach on our risk and other initiatives. I mean, if you think about it, we are working ourselves out of business. Our contract, if everything goes right, we could be the last contract in liquid waste. So our goal is don't do something that's not going to benefit the program, that it does not make a difference to. If the M&O has got to do work because of tritium and some other things, then let them follow those rules. Because we are really going out of business, there's no reason for us to follow some of the rules. So we do try to take a graded approach. We work with the customer to make sure that they're on board with that. But if we can find a way to do it quicker and cheaper, not having to play by some of the procedures that we've had out there since DuPont was on site, we're certainly going to take that as an option and take a look at it. This is the SDUs. So these are line items. The way the line item project was set up, if we are cheaper and our schedule is faster than what was estimated, then that's really driving a reduction in cost for the government. It also is part of how we are assessed, how we're graded in the work that we're doing. Right now, we are about 22 months ahead of schedule on the SDU project, and $60+ million, I believe, under budget. So that's just good work, good teamwork. We've changed kind of the way we've operated. We used to demob, and we've kind of gone away from that. We've got a contractor, and we just keep him there. We want that contractor to do all the work. Don't go home until you're done. And that, once you just continue that, that's a real money saver for us. If you got to start and stop, I think everybody knows that gets expensive over time. I think this is probably the slide that's the most telling, and I have shown this to a lot of different people. If you look at the age of our facilities, the tank farms are 70+ years old. So you can imagine buying parts for a 70-year-old car is pretty hard. Buying parts for a 70-year-old tank farm is a whole lot harder than that. There are just not a lot of vendors that do this work anymore. You'll see that the newest facility, that's SWPF, where Steve worked. Saltstone is 35 years, ETF is 37, DWPF. When I started work, it was a group of us, and we got to be the last people that got to walk on top of DWPF before it went hot. So that tells you how long that's been, but that's 30 plus years now. This is the glass waste storage buildings, which are almost 30 years. This is the two buildings where we're storing the canisters, the vitrification cans that we would have at Yucca Mountain if we had a choice. But that's what those are. We're double stacking those, so we're not going to have to build any more of those facilities, but they're very expensive. As you can tell, everything here is old. It is really difficult to find pieces and parts. It's even hard to find resources. If you think about it, we've got a lot of people that have retired over the years. Our attrition is about 8 or 9% a year, and a big portion of that is retirees. And they have worked out there for years and years, so they've probably got more information in their back pocket than a lot of people will ever have. So when we lose one of them, it makes it that much harder to get work done. So we do everything we can to keep you out there as long as we can. But this is just an example of how old things are. Critical spares, recapitalizing a lot of these facilities is key to us staying up and running. It's key to how we're doing our business. When I first when I was a CFO for SRR, I think the most we had ever done from processing standpoint, and it was not SWPF, it was a couple of different facilities, was about 1.2 million gallons. And last month, we processed 727,000 gallons through SWPF. So that tells you what that system is capable of. And as long as we can keep feeding it and we can keep the other facilities up, this thing will do it. It's going to be the horse that we ride out on. But it's the people that are working on it are dedicated, and like I say, this place never shuts down, and we keep it running. And that is all I have. Yes, sir.
Willie.
Willie Priester, CAB. Got a quick question for you. It seems like in your explanation of your presentation today that fiscal efficiency is the order of the day. My question is, how do you do that, and do you have work groups that look into finding ways to root out efficiency in what you do?
Yeah, we have, I'll give you a perfect example. So we have the acquisition process for us is lengthy. There's a lot of front-end work for engineering, QA, all that work has to be done on the front end before it ever gets to procurement. So procurement is mine. All that front-end work, though, still has to get done before it ever comes to me. So we can take a document that we need to put out on the street for competitive bids. It'll take us, say, 10 days, 2 weeks before we get it on the street, and then we're waiting on vendors to supply or reply. All of that 6 months or a year's worth of work on the front end is we've got a team that's focusing on how to do that cheaper, better, more efficient. So we've got some AI tools we're looking at. One of the things we've struggled with is finding vendors. So we've got the team that's trying to build this product for us. Not only will help put the specs together with the latest requirements, the latest technical requirements, it also looks at the vendors out there in the world that provide that product. So if it's a compressor, it'll look at what Ingersoll Rand has for a compressor. If there's another vendor, it'll look at that. So you can decide what kind of compressor you want, what kind of characteristics you want, and you can do that on the front end. So that takes that 6 months or a year's worth of work and shrinks it. And if we can do that, then we can process stuff and get it in faster and faster and faster. So that's an example of what we're doing. We're looking at in the payroll section, HR section. We use an older product. It takes a lot of resources. So I've got 2 accounting, I think 2 people in HR, and the majority of their time is doing reconciliations on Excel. between our accounting system and our cost point, the time and expense system, and what we've got for payroll. So we're looking at a new product that takes all that away. All that stuff is now done in-house. We don't have to have people doing work outside of the system. It uses AI as a tool, so you can go query it, you can get the information you need. If you want to know how much it costs for us to replace somebody that left, we can tell you that. So all that data is there, which reduces the cycle time, saves us money. We don't have to, if somebody leaves, we don't have to replace that person. You know, now if there's something for them to do, that's fine. But if they leave and I can do it for less people, then that's the route I'm going to take. You know, I think in program support, there's about 200 people, something like that. And if we could figure out how to do it for 100, we'd figure out how to do it for 100. I mean, really, that's the key out there is finding initiatives that save us money, save us time, and put money back in the program. So that's two examples of what we're trying to do right now.
Okay, we'll go to Wanda and just make our way down the table.
Wanda Jackson Cab. My question is about the robots that you had mentioned earlier. In that position, what would be, have you guys even sought out what type of robots and what will they be doing different from the process is of what you're doing now? Well,
Today, a person has to go do a lot of that work. We had a contamination event in 136B over in SWPF. And the rad rates were so high in there, it took us months and months to go put lead shielding and blankets in there just so we could get somebody to go in there. Wow. And even then, they were only in there we had to manage the amount of time that they were allowed to go into that room. So as you can imagine, if you got a robot that can go in and do the same thing, in he goes, you know, that's what we're going to use. So that's an example of where we use robots everywhere we can. And even outside of the robots, in DWPF, if you look at the canyon or the dark cell, right? We've got overhead cranes and all this equipment in there. You can't go in there, right? But you've got the ability to use the cranes and the tools that have been built to go do work inside where a man can't go. So we do what you're talking about with antiquated cranes and things like that, but the technology is just getting better and better. Years ago, I had an engineer I was talking to, and he said, you know what, we land a man on the moon out here just about every day. You know, and if you think about it, we do. I mean, you can't go into these places. It takes technology, it takes robotics, it takes people with a lot of ingenuity to come up with ways to get in there and do work. Because, you know, you or I, it doesn't matter how much PPE we got on, we can't go in there. So the robots are really going to free us up as we go along to be able to do more work. They will stand up, they will contract themselves, they will go where we can't send a human being. We've got, you know, we practice with them, we buy specific tools. We use 3D printing to make different tools and different shapes that we can use for a particular operation that we need. So it's just going to become more and more. As the world goes to that, we'll see a lot more of the untethered robotic kind of things, and we'll use as much of it as we can.
So will that also cut back on staffing?
It takes, I don't believe it will, because the amount of work that we have out there, we need every hand we can get. You know, you still got to have somebody operating that. You still got to have somebody there to create a path for them to get into the room. There's all this upfront work that a robot can't do. I mean, we're sending a robot in at the last minute, right, to go in and block and tackle and do all the hard stuff. But you still got to do all that front work, that upfront work, the upfront engineering. That doesn't go away. I don't care what you do. So no, I don't believe in my lifetime that'll ever happen. We don't have you know, there's no avatar that we can use to do this work. It is still people. It's still equipment. And we've got the best and brightest out there.
That's great to hear. Thank you for your presentation.
All right, thank you. James?
James Schecht, CAB member. Quick questions, just being the newest member. If you could clarify two terms you used, M&O, what does that stand for? And you referred to customers a number of times. Who are those customers?
So the M&O contract, so when DuPont and Westinghouse took over from DuPont, that was a management and operations contract. That is a letter of credit contract. You're basically acting as an agent for the federal government. Our contract is different. So our partners have had to capitalize our project. So they've had to put their money into an account, and we use that money to operate on until we get paid. So the partners have got a lot of skin in the game. Some of these big projects, you might have 3 or 4 partners, and they may have $100 million of capital tied up, and you don't get it back. It stays in the project until the project is over. I tell the BD people all the time, you can either have your fee or you can have your capital, but you don't have both. Because I got to have that money to operate on. So that's what an M&O contract is. It's a letter of credit. You basically tell DOE or the federal government, hey, I need to have X amount of dollars. The Treasury puts it in an account and you draw that down. So for us, we actually have to create an invoice and send that to the government, and then the government reviews the invoice and pays us.
So the government's a customer.
Yes, sir. Our government is the customer. Yeah. And there's not a lot of companies that do this. I mean, you think about the risk. I mean, this is the most dangerous place probably east of the Rocky Mountains. So you have a bad day out here and you've had a bad day. Your liability could be in the billions. So there are not a lot of folks that step up and want to do this work. I mean, it is dangerous work. It is cost reimbursable work, but you're taking the liability and the risk on you. So the partners are very careful about how they operate. We have an operating agreement that we operate under, and we're careful. It's their money. We're careful with their money. I get phone calls constantly. Where are we at with money? Where are you at with cash flow? I can tell you at any point in time during the day how much money we have in the bank and how much we're going to spend tomorrow. And that's how closely we manage our money. We can't, when I was first married with my wife, we would get down to the last of the month, and there's about $20 in the account, right? Well, we can't do that. If we don't have 3, 4, 5 million in the account, one payment to a vendor could take all of that. So that's how close we operate in order to protect the partner's money and to make sure that we get the work done.
Thank you.
An easy way to think of it, and it's somewhat pithy to say, is that no one works for Savannah River Site, but 13,000 people work at Savannah River Site. So the overwhelming majority are contractors to the government, and less than 1% are actual federal employees. So.
Yes, sir.
I got my math right there, right, Edwin? No. Good. We're not going to get misquoted anywhere. All right, good. Sally?
Right.
Actually, mine was just a comment, really. Thank you for your presentation. Actually, we can really see how the usage of drones as well as your robotic technology, that is really helping us a lot in
Yes,
reducing the cost.
Yeah, and we get better at it. The more we use it, the more we find out what it's capable of doing. And now when we look at a particular room that we have to go into or whatever the environment is, we will spend time trying to, how big is it? How much room do we have?
Yes.
Will this robot work? Can this robot turn that valve, whatever it needs to be? So when we get a robot, all of those are part of the considerations in the robot.
Yes.
You just can't get one for the sake of getting one. It's got to be something that can do the work, pick up whatever it needs to be. It's just like a human being. I mean, it's got to be able to manipulate an arm or a hand or whatever, so it's got to be capable.
Yes, thank you.
All right, Pat, wrap it up for us.
Pat Kilroy Cab, one simple, it's kind of a technical question though. You were talking about filling up the old tanks and how many loads, and I know that the grout is manufactured on site. I wonder if it'd be cheaper to pump it to these tanks.
Well, what we'll do is when we get ready to grout tanks, we will grout a group of tanks. So it'll be right, say we'll have 4 tanks right here. We'll put almost a hopper in the middle. We'll feed that hopper, then it's going to feed into each of the tanks.
But then you have a truck carrying each.
Yes.
But I'm saying.
You talk a batch plant. We've looked at bringing a batch plant on site and doing it.
Yeah.
So we're always poking at that, trying to figure out what the best and cheapest way to do it. The problem with a commercial company that does it If you put that batch plant on site, it will never come off site. So the investment, that's a lot of money to tie up in a batch plant that this commercial company is probably not going to ever be able to use. And we can't take it off site and go pour somebody's driveway.
Yeah, and then I kept thinking about the trucks going back and forth,
Yes.
the cost of that.
It's not cheap, it's expensive.
Okay, thank you.
You had one follow-up, Wanda? This is going to be it, folks.
Yes, Wanda Jackson Cab again. My follow-up question is, how many tanks do you have now in the process of being cleared? Or is there?
How many tanks do we have that we're working on?
Yes.
We got 8 that we've got that are PCWR. They're ready to go. And then we're constantly working on, we got 3 that we're working on this year. I think we've got 2 that we're working on next year. So we're constantly working on tanks, getting them ready to close. So the closure part of this will be when we get to the point where we got enough tanks all piled up together, ready to go. And then we would go in and start grouting those tanks. I mean, from our perspective, it's better for us to go clean the tank out and get it ready for grouting. Then we can grout them. I mean, if you got one ready to grout today, then you're really spending money that could be better used on cleaning a tank out. And then you can get up to the stage where you would grout. So it's more effective. It reduces the liability quicker, the environmental liability and risk. So that's kind of the method we're using to grout tanks.
All right. Thank you, Brett. Appreciate it.
One more question.
Oh, come on.
Just one more. On your, Deborah Crease Chair, on your funding budget, I'm looking at the direct labor costs.
Yes, ma'am.
But I'm also looking, is that directly included in the training, like the classroom training, also the classroom training?
It would be.
Okay.
It would be. Yeah, the direct labor includes everything, all the care and feeding for those people that are doing the work.
Okay.
So it's their labor benefits, anything that they've got to have in order to make things go, in order to keep them safe and protected. That's PPE, trucks, equipment, whatever it is that they need. You know, breathing air equipment. It's all part of that cost. All the cost to take care of those folks.
Yes.
All right. Thank you. Appreciate it, folks.
All right. Thank you.
Yep. All right. Come on up, Bert. And we'll move into legacy true waste disposition.
We'll see. We ready? Okay.
I think so, yeah. Clicker here if you need
My
it.
name's Bert Krapps. I've been out at the site on and off since 1986, so I've been there a long time. I'm the DOE Nuclear Materials Program Division Director, and today I'm going to talk about our Legacy True Waste program. So asking you to change gears. Liquid waste is one of our radioactive waste out there, and then transuranic, something different. So you'll see as we walk through this. The CAB a couple years ago basically provided a recommendation that we would try to accelerate and finish up the legacy waste program. Well, I'll explain kind of how we call it legacy waste in a minute. And so this is kind of an update on where we are on that, and we're actually doing a really, really good job at getting to finishing this program up here in the next couple of years. So today we're going to talk a little bit about the history so we can kind of get grounded on the legacy waste and then where we are with operations on it, and then we'll walk down through to get to the final inventory today and then kind of note where we are with priorities with finishing it up. So from a history perspective, the waste isolation pilot plant that we call WIP is actually out in the state of New Mexico. It is a geological disposal facility. It's basically, the waste is about 2,000 feet below grade in a salt formation. And it started operation back in the late 90s. It actually was constructed prior to that. And so it's fairly old, just as Brett mentioned earlier, and Steve, these facilities, a lot of the facilities in this country that are part of the Department of Energy are fairly aged facilities. When we were basically identified that we were going to start managing transuranic waste with the department, It was before WIP was built, so we started segregating the waste at Savannah River and other sites. And some of the waste actually we referred to as buried retrievable, and that's what it looked like for us. They basically was above earth, and we mounded them with dirt, and we referred to as retrievable buried true waste. When we started actually shipping waste back in 2001, I believe it was, at Savannah River, we had accumulated over 30,000 containers. We just had a lot of these storage facilities just loaded up with drums. They were on pallets, and they were about 3 stacked high. We talked about the buried true there, and then because we generated this waste before the WIP facility was open, they made some changes both in how we were going to ship the waste. By the time we developed a shipping container, it had evolved several times, and so we got down to basically a 55-gallon drum was going to be the unit we would start characterizing and shipping to WIP, which meant we had a really challenging process we were going to have to do. A lot of the waste was generated with very little records. We did a lot of the generation when we didn't have a whole lot of information on the waste stream, and so WIP does a very extensive characterization process. What they do with each container is we have to X-ray it. We have to verify we know everything that's inside the container. WIP does not want any liquids, so if you have any containers that have liquids in there, you would be able to see that in an X-ray shot, and then you would know that that won't be acceptable. Containers, they don't want large containers that are sealed because of pressurization you may have. And so those are the kind of things. So every container before it goes to WIP has to be X-rayed. Another thing we do with each container, we have to assay it. What we do when we assay is we determine the transuranic concentration in it. And a lot of our waste, when we generated it a long time ago, when we actually went and assay it, WIP requires it to be at least 100 nanocuries per gram radioisotopes in there. We found some of our waste was less than that. So even though we were storing it and managing its true for many, many years, once we started characterizing it at WIP, we found that some of these containers did not meet the WAC acceptance requirements for WIP. So then we were able to just dispose of it. If it was just radioactive waste, we have an on-site disposal facility. If it was mixed, meaning it had a RCRA hazardous component to it, then we would have a facility off-site we had to go find and dispose at that facility. So through the years, you can see where we've been here. We've done over 1,700 shipments to WIP and over 35,000 containers. So we've been working this program since the early 2000 time frame. So as I mentioned earlier, these are our storage facilities where we basically house the waste today. You can see they're basically a galvanized steel tubing with a canvas type cover on them. They do have a impermeable concrete sealed floor. They do meet the RCRA requirements. They basically are sloped and they're able to catch any liquids we have. But as I mentioned before, when we generate we repackage it, we removed all the liquids. So it's a very low risk that we would have liquids in this material today. As we go forward here, we're talking legacy at the moment. We do have new gen. That basically means we're generating it now versus historical waste. And then we also have another waste stream that's part of the TRUE program today, and that's referred to as our plutonium disposition. And that is basically where we're taking the surplus plutonium, we downblend it into an acceptable shipping certification characterization form in K area, and we're shipping that material as well to WIP. And then the new thing that I'll talk about a little bit more here in a minute is we're also, when WIP, they had an event back in 2014 we refer to as a drum deflagration. It basically, the material reacted in the drum. It actually kind of burped, exploded, whatever you want to call it, released some contents inside the mine at WIP. And so that facility was shut down for several years because of the radioactivity. And also there was a big question in our waste characterization whether or not we were doing something wrong, that we could potentially bring in additional drums that would have that reactive thing. So we basically paused both the operations at WIP and all the characterization operations for that. So when we resumed it, one of the things we used to do out there is that this is like a room in the WIP. If you were in the mine, you would have a room like this and you'd see all these waste containers around there. The remote handle, because it was a higher radiation coming off of the container, we didn't want to have personnel around it when we were doing the operations and bringing it into the mine. They had a special piece of equipment, and we'd actually bore into the side of the wall, and then we'd place these containers into the wall. They would come on a different shipment to the facility, and they would be loaded in a different type of location at WIP. When they resumed operations, that was going to be a very expensive part of the process to resume operations, so they basically stopped that, or they didn't bring that back up. And today we do not have that operation out at WIP, and it would be very costly to bring it up. So we're going to another type of approach for especially small sites that have a small number of these containers that are high rad, referred to as remote handle, and I'll talk a little bit more about that. Just some recent accomplishments. So you can see that we continue to make some progress annually on this. The large containers I mentioned earlier, a lot of the shipments when we first started back in the 2000 timeframe was just only 55-gallon drum waste. We realized we had larger container true waste. We didn't want to go in and do a lot of size reduction if we didn't have to. So we basically went out and looked at what kind of particular container we could then build that would pass the shipping requirements for these containers. These containers, I'll pause here for a minute. These containers, when they go on the road, they have to go on what the NRC license is referred to as a Type B container. It's a very robust container. That goes through extensive testing, including fire up to, I think, 14,000 degrees. It's actually drop tested 30 feet or so on a spike to make sure the container would not breach. And so when we built the first true pack that that would ship the 55-gallon drums, we needed to come up with a box container. There's some challenges with box containers from a seal standpoint because you're dealing with corners, whereas you can appreciate a regular round gasket's fairly consistent through the process there. One other thing about these shipping containers, they're also considered double contained. In other words, you have an inner and outer container from robustness. So we had to go basically design and build these true pack 2s are referred to. They're box type containers. They're loaded on the back. There's a door in the back, kind of like a very robust Sealand is the best way to describe of it. And Brett was mentioning it earlier, talking about how we're losing these skills and companies. This became a very big challenge for us because we had a hard time finding a company who could build these in the United States. And we found a company way up in Seattle, Washington, and we built about, I think we built four of these, and one of them we had issues with on the testing of it. And so I think we got 3 in the fleet today. But we had about, I don't know if it's on here, it's not. I think we did a little bit over 100 shipments of this box waste. Saved us a lot of time and resources by being able to ship in a larger shipping container. This is the crew out here as we celebrated one of the shipments here. So we talked a little bit about this event at WIP and how that kind of changed how we went about characterizing waste moving forward. So to just give you some appreciation of the challenges we have. So we've made some changes with the generators, which is the sites that produce waste such as Savannah River. There's a lot more paperwork involved in it. It's basically a lot of more checks and balances. There's independent reviews that we have to do for the material. It's also, because it's legacy waste, we don't always have the history. So there's a little bit of this risk that we have to decide whether or not we want to take or not, depending on the unknowns in the container. And now that we're down to the very small remaining legacy waste. Those are the containers we've basically been pushing to the side and not shipping because of those challenges. So you're going to hear as we move forward and updates in the future that some of these containers we're really going to have to decide at the end of the day, are we willing to take the risk with the unknown information, or are we just going to have to let them sit for a period of time and figure out another way before we can safely dispose of them. And then the last part of that is that as we go to package these containers, we still do what we refer to as overpack or repackage them. Some of these containers the waste does not have the sealed drum in it because they're old drums. And so we'll put them into a container, so a little larger container. And we may have 3 or 4 drums in there that we think is the right waste stream that we want to ship, and then WIP goes and does some paperwork and finds that one of those containers is not acceptable and the other 3 are, and we don't want to hold up making a shipment, so then we'll have to go in there and repack and remove one of those containers. So we have a little bit of challenging on that. And then as far as shipping concerns, and this is kudos to both the department, DOE, and the collaboration we've had with the state of South Carolina over the years. Some of the states actually have a legal driver to get rid of their legacy true waste, and they have annual commitments. We work really well with our state, and we never got into those type of agreements. And we didn't, and looking back, we didn't have to. We were able to move the material and get it at a priority waste stream. But right now, we don't have a whole lot of waste, and it's very challenging. So we only need to ship about 15 to 20 shipments a year to continue where we need to be. And so some of the other sites have the larger waste streams, and they have these regulatory commitments, but we haven't seen any impact on our ability to do what we need to with our shipments with those. But there are other states you'll hear about that have these true waste commitments there. And then remote handle, I want to just talk a little bit about that. That was what I was mentioned earlier, that in past operations out at WIP, they would put it into the wall. We're now going to a shielded container. And what that means is these containers either have real thick steel, or they actually have a lead lining to them. We'll put the 55-gallon drum into those. We only have about 150-ish drums we need to do this with, so you can appreciate it's a small amount of material or fall around waste containers. But we've purchased some of these. We've already received 25. We're expecting to get another 50 in the next couple months. So we hope to start shipping these next month. So hopefully we'll give you an update. Maybe I can get Edwin and we can let you know when we do that. But we're real excited to start shipping that. Otherwise, we would maybe have to wait many, many years to see if WIP would ever open up the remote handler program. This way, it basically will go in with the other containers and just come in. They can basically handle it and bring it into the room at the WIP facility just like the other way. So that's going to be a big plus for us. They are expensive, but time is money, and it also helps accelerate the program for us. Here we are with the inventory. You can see right now, as of the last of April, we got about 128 containers. You can see we refer to as contact handle. That's the RAD is low enough that safely we can handle it with personnel. With some of the overpacks we talked about earlier, referred to as the standard waste boxes, we can put drums inside of those. And then, as mentioned before, the remote handle is about 153 containers. So that's kind of where we are with the inventory. And you can see our projection of where we are with the shipping of that and disposition it. We're trying to target to finish that up in 28. And we're basically right now on schedule to support that. Priorities here for us is that we're going to continue to work at the shipments that we've discussed here, around 12 to 15 a year. And then, as we mentioned earlier, we're going to start doing the remote handle shipments. And what you have here is how we kind of package some of these containers. You saw the large storage pad, so we do have space on that to do these operations. This is what we refer to as a RAD hut. All of it's a plastic type. As you can see, the frame tubing in here. It allows for the control that we need. And this is a stick crane in here, and you're seeing where we basically would repackage and remove the lid from in there in the container there. So that's the picture of what you're seeing there, some of the operations we do with the repackaging of the true waste before we ship it. And I believe that's it. So summary is we're continuing to make progress. We're working toward the 28 date that y'all recommended in your recommendation. And this year we have, as Edwin reported earlier, we've done 19 shipments, and WIP has been in an extended outage for the last couple months with some hoist issues they've been dealing with their aging facilities. They resumed shipments this week, and we expect to resume our shipments on Monday the 27th next week. So that's going well, and everything seems to be working for us. We've had no issues with our shipments, and compliant, and everything else has been going well. And that's what I have today, I believe.
Any questions for Bert on the True Waste Program? Pat, we'll start with you.
Just one question.
Yes, sir.
Pat Kilroy Cab. That one thing I was wondering, is there any more 55-gallon drums of material still buried somewhere?
No, I don't believe so. Yeah, we have, you talking about from a true waste perspective?
You got it.
Yeah, right now, all of the waste that we have as true waste has been recovered. That was retrievable buried, and we currently have them all over there in the area. So there's no other buried areas that we may find true waste that I would be aware of.
And they're all in one storage area, just?
Correct. Now, as we go forward, now he's talking about future waste. As we go forward and we start doing these decommissioning and deactivation of these nuclear facilities, we will probably end up generating true waste out of those. There's probably some glove boxes and some other stuff in those things that we may decide to cut up or what have you and bring those out as we work with the deactivation of those things. And that might be some challenging waste, but Hanford and some of the other sites have started doing some of their glove boxes and hoods and stuff like that. That's got plutonium in them, and so that's probably for us would be the challenging with the next, but it would still be considered newly generated true waste.
Okay. And the other thing, I'm wondering if some of the new people in the cab understand what waste you're talking about.
So transuranic waste for us is mainly what we refer to as job control waste. It is people who work in operations that are in nuclear facilities around plutonium. There is we refer to as contamination. There's things where we get plutonium on. It could be mainly tools. It could be process equipment such as pipes and pumps and what have you like that. Respirator hoods, various things those operators work in there, those kind of things. And so we generate that waste during normal operations. We also have, as I mentioned before, over in K area, there's that surplus plutonium that we've been down blending, that we've shipped that as a plutonium material in a can. And then also we have future missions out there will be generating new waste. We have the pit that will generate transuranic waste, as well as some other NNSA, and as I mentioned earlier, deactivation and decommissioning, we also would generate. But it's mainly anything that comes in contact with plutonium for Savannah River. And we do a lot of plutonium operations. Even the National Lab will do research, and they will generate various things such as vials, process equipment, gloves, various things they operate. But all of this has trace amounts, in most cases, plutonium, and it doesn't take much to get to the definition of transuranic waste.
Okay. Any other questions or comments around the table? Seeing none. Bert, thank you so much.
Okay, thank you.
All right, one more presentation before lunch. Susie, you got the unenviable position of leading us in.
And greetings from the gallery. You guys are hanging tough back here. I hope my presentation gives you a chance to exhale. We got a lot of smart people at the Savannah River site, don't we? Makes your head swim a little bit. Just a little bit about me. If we're continuing the theme about being a resident, I'm a native of the area. I was educated in the Aiken County Public School. I'm a second-generation worker. My dad was a mechanical engineer for 41 years at the Savannah River site. I'm the only kid that stayed home, but I'm not an engineer. I started out as a PR person and have gone through 38 years of great assignments, and to me, I think this one by now is the most important. I have a lot of passion as a local kid, and our historic preservation program is near and dear to me, and I know we had new CAB members come to our curation facility. How was it? Okay. All right. Well, we're going to go a little quick. Remind me as an old timer, I will try very, very hard not to talk in acronyms. It's a hard thing to do. It's like being in the military, I understand. So let's talk a little bit about historic preservation. I'm going to kind of catch you up from the last time I was in front of the CAB. We've had a little bit of a name change. We used to be the Cold War History Preservation Program, and I'm going to tell you we're far past the Cold War right now. Remember, preservation is we preserve from 1950s onward, okay? Primarily, next slide. Or do I have to do it? I'm sorry. Man, talk about a little princess. You want, I got to run my own slides. So, yes, history's fun. Yes, history's cool, but we're doing it by law. The National Preservation Historic Act tells us we have to preserve. And that's kind of the toolage. There you have President Lyndon Johnson signing it in to act. And what does that mean for the Savannah River site? You guys, when you were out on your tour, you saw a lot of old buildings, didn't you? A lot of concrete, a lot of asphalt, a lot of equipment. Well, a lot of that equipment today is very, very instrumental in saving because it tells a history. I think by now, you folks, if you haven't gone and done the quick and dirty history, this small town in South Carolina helped save us from the Cold War, to help us win the Cold War. And it's quite an honor to tell the story, and that's why I tell a lot of anybody, unlike Brent Evans, that'll listen to me, is that we have a very unique story to tell. Los Alamos does with Oppenheimer. Well, let me tell you, we were the next in queue, and the technology and the people that brought us there is just as important to save. We have a programmatic agreement with the National Nuclear Security Administration at Savannah River. Also, DOE helped us get off the ground earlier in the years. And what does that programmatic agreement does? Well, basically, it develops with our stakeholders and our advisory council. I'm going to try to walk out of your way, sorry. Those agreements, and we do have a lot of stakeholders that get involved. For example, you here today. That's why I'm here talking the Citizens Advisory Board. What we do is we identify facilities for preservation. That's going to come into play as we're starting to change the landscape and doing new mission work with the NNSA. And also we write histories, we collect artifacts, and my favorite, public outreach. And this is just one of our photos. I have a good job on site. I have a gentleman on my staff, Kevin Fowler. I think some of you may have met him on the tour. Kevin's never going to be able to retire. I have 400,000 photos to digitize. We're only 100,000 in. So folks, stay tuned. We'll be talking more probably in the next coming years. Resource identification. These are some of our earlier photographs. We have 220 Cold War resources identified, and they are National Register eligible in the Cold War District. And you're going to say, Susie, what in the world does that mean? Well, let me tell you what it means is if we adapt, change, or get rid of those, we have to make sure we have the history of these facilities. Now, some of you folks are kind of new. I'm just going to point out quickly, this is actually the 703A administration building. You know what's missing? There's no badge office. So iconically, the historical photos of the Savannah River plant, which we know is the Savannah River site today, it's a pretty extraordinary resource and development, and we capture all those. Soup to nuts, oral histories, the outlines, the photography of those buildings. I have a phenomenal team. I am very honored to work with these people, and I always want to point them out. When I go out and talk to people, I am not a historian. I run the program. I make sure they get paid. I make sure we're on task with the client, NNSA or the Department of Energy. But Mary Beth Reed, she's actually briefing my Vice President, Andy Tisler, when he came down to see the museum for the first time. And then Josh Blackman in the center. Josh, phenomenal historian. He's challenged with doing the oral histories. And I promise you, when you spend most of your career out here, like a lot of our retirees for 38, 40 years, they're not at a loss of words. And we have to capture that history. You're going to start hearing a lot as your tenure on the board about knowledge transfer. Has that come up in any discussions yet? No knowledge transfer? That should be, because you're starting to see our workforce start to turn over. A lot of folks are retiring. That knowledge they're taking with us. We're taking that history, taking those stories, and then, of course, in the deeper in the facilities, our operational facilities, there's definitely a more robust knowledge transfer program. It's very, very important in our history, because these folks are starting to retire. And you know what? Some of them don't come back. And once they're gone, they're gone. Aaron Anderson, if you come on our tours, and that goes for the gallery, if you guys, if you're employees or if you're for the public, we'll talk a little bit more about those tours. Aaron is our lead curator. There's Kevin Fowler in the center, our digitization expert, and Melissa Hansen's been with us the longest, about 11 years. Andy, my client's probably watching online, and then me. So we have a good group of folks. Since we met last, I'm always going to focus on our compliance. Our head chief historian, Eric Doyle, came down and visited us right in January to benchmark, see how the program was doing. Had a great visit with him, showed him some of the work that we were doing on site in the curation facility. The annual report is on your desk, and we just got that completed. We do that every year for the client and also for our community to show what we do. And I will tell you, since we last met, we did a lot with the 75th anniversary of the Savannah River site. I'd have to take over your whole schedule to tell you what we've done. So it's right here in a nutshell, and it's pretty entertaining. So when I leave today, if I've left something out, hopefully it'll be in the report. And then, of course, finally, the negatives. Kevin's cranking along at 7,392 just in the first quarter, and I'm really proud of that accomplishment. You see him in some of the scanners in the foreground with him. And then 717A Central Maintenance Shop for NNSA Research. Let me tell you what that sentence means. We're looking at some buildings on site, our client, the National Nuclear Security Administration, and looking at what can we reuse rather than trying to fund new infrastructure. And that, we actually done the historical preservation assessment for 717A early on when we were taking down the site footprint many years ago. Well, luckily we had it in the barrel. We were able to take current photos, and they're going to be able to reuse that for some of the mission work. So that's the type of work we're starting to roll into more now, is just making sure facilities are compliant. We've got the history, and then we can clear it so the client can come in and get back to work. We're working with the National Lab. They're changing out some laboratories and things. We're working with them to get a preservation planning team together. Our historic advisory team is very important on site. We take people from our records. We take people from our classification office. The different subcontractors that talk to you from across the site. We talk about history. Are we collecting the history? What have you found? You know, I will tell you 99.9% of my job is telling new employees, if you've just moved into somebody's office, don't throw anything out. You're saving history. Also, just doing a lot of, we went out to the F area laydown yard. You may have seen it from the bus. It used to be an old laydown yard for F Canyon. Then they have some pretty neat old equipment, things that was kind of the spare parts yard, right? So we went ahead and just assessed that, because I believe SRPPF down the road is going to use that for perhaps a parking lot or something else. The fire towers surveys were important. Those were early on when they built the site. They had a couple of them outside the site, but that was also to not only look for wildfires, but also some of our air monitoring and things of that nature. So with 198,000 acres, 320 square miles, you got to keep an eye out on what's going on around the site properly, and that's what it did. And the artifacts continue to grow. Now, some of you have been to the on-site 315 Mike M Curation Facility. She's an old girl. She was originally designed as a warehouse in the M area, and she was retrofitted in 1982. But with retrofits comes some challenges. This is not the Smithsonian. This is kind of tough when you have humidity like we have today. Look at my hair. I stepped out and it got growing. I'm like, yeah. You know, I was out west at meetings last week and it was perfect. But humidity and rain in the South is not kind to artifacts. In 2011, we modified to house the artifacts. And what does that mean? That means putting in a dehumidification system, building out storage and rooms and things of that nature. So it's a sheet metal building, roughly 27,000 square feet, and it was retrofitted of this roof. And I think this will be a career achievement for me, because I'm here to tell you folks, I know everything there is to know about a roof. I had structural engineering, and the things about this is before you put on a retrofit roof, let me tell you, it's not like you call your team, you know, when you go and get a new house and they bring out the shingles and you just watch them, you know, climb around, they get it done. No, this is a warehouse. So we had to study to make sure a retrofit, a thin line, another layer wouldn't what? Be extra stress to the infrastructure, right? I'm looking at my expert over here. A lot of things, and we got that done in a very timely manner, but I tell you, y'all, if you had come to visit me 2 years ago, it's embarrassing because we had buckets just to hold the water. I had the far wall of the whole facility, just every time we had a rainfall, it would come in, and we could not, and we are driven by compliance to keep those humidity levels down. So it was a challenge, so I'm very, very proud of that. The other one was a fire suppression system. The way that I don't know if our laser works, the way the water would leak to the roof, it would go down that main support beam, and it corroded the support beam, so we had to put that in there. So I'm not going to come up and say everything's great at our program. We have our challenges. And my next challenge with infrastructure, and y'all are going to start hearing this, right? Savannah Riverside, 75-year-old, you know, we're past the Botox stage, okay? We need past a facelift. This is some crucial infrastructure, and even if it's historic preservation, it's important to me as well. I can't save history if I don't have the equipment to do it, right? Make sense? Yes. So I have 6 21-plus-year-old facility or HVAC units. You see them there on the screen. They're 2010 models, and I promise you folks, I won't tell my engineers who are helping me keep them up and running, but if it wasn't duct tape, bubble gum, we've tried everything. They're also they've got some coolant there that needs to be replaced. That's no longer, but they're old. You can only bandage old equipment for so long. And this, again, isn't for my comfort or our team's comfort. This is making sure we're keeping our humidity levels within compliance. We're saving that history. How many of you in this room have saved stuff in a cardboard box in your garage? Raise your hand. I'm raising it. I do it. How'd that work after 3 or 4 years? What'd you find? Not so good? Ooh, you know those cockroaches love paper in a cardboard box. Doesn't do well, so that's my free tip of the day. Do not store old paperwork in your garage because it doesn't last, okay? So I make light of a very, very situation, but I want to give you guys kind of the thing is that's not what we do. And if you've come and visited the facility, you see that we also share the space with USC Archaeology. They preserve the history pre-1950, and they have some very, very precious artifacts in that nature. So it's very, very important. So we're past the heating contract association's limits for lifespan. A lot of costs going into it, folks. I mean, I can squeak blood out of a turnip working for the government, but I tell you, I just look at my engineers and say, talk faster, you're on my clock, what do I got? You know, that kind of thing. So we're really looking at that. So we're working on a path forward with NNSA. Keep your fingers crossed. Hopefully next time I can come back or y'all tour, maybe we'll get some infrastructure, but it's a challenge. as you're hearing it through the other contractors in here, budget matters. It's a challenge, and I'm historical preservation. So you can see I'm passionate about it with our budget people. So my background's communications, tourism and outreach is near and dear to me. Love to talk history about the Savannah River site. If you see me at Publix, you're probably not going to go down the same aisle because I like to talk about it. So we really stood up a tours program within our public tour program for the site, and we work hand in glove with Savannah River Archaeology. We had 93 visitors come this spring. We got 4 coming on October. If you want to jump on one, go to the SRS homepage. You can sign up, because what's really cool is you not only come and see curation and see everything I'm talking about, but our archaeologists tag team with us, and we take you to, it's Dunbarton in the spring. It'll be Ellington. So you go to the old towns. We let you see what it looks like. It's pretty cool to see some of the old towns for sure. We've been busy with new hires. Again, not only am I telling them don't throw anything else, is we're seeing different things, like people that are different from me, that generational workers. Now we're seeing people coming across the country that have no background in what we do. They don't understand the history. Why is it important? Why does it matter? How are we part of the nuclear deterrent for our country? It's a big deal. And if you haven't grown up through it or lived in the central Savannah River area, there's a big educational piece. So our team, including our archaeologists, I'm one person, or excuse me, our curators, we all rotate through. I tell you, half the time, I mean, I talk to the SRMC employees, I talk to the National Lab employees. Again, we talk to anybody because it's important for them to understand that history. Definitely the Sertoma Club. Matter of fact, our historian was at the Aiken Rotary Club meeting yesterday. We are big in our community because it's important to share our story with our community. Why? Why? We could not operate without the support of our community. And I know everybody on the back wall who works for the contractors, we understand that. We can't operate without our community's trust. And like I said, we are always out talking the history of our site. We would not have the license to operate if it wasn't for the support of our community. And I mean that sincerely, because I are one of them. I am a local. Our employee tours are going up, so that's gone really well. And then if you are fans of the Savannah River site social media or any things like that, Twitter and all that historical, Throwback Thursdays, all that photography, guess where it's coming from? It's coming from us. So we help the public affairs folks with that, and that's kind of neat. And then our safety expo you see back here, that's, if you don't know what that is, it's kind of a big 2-day event where employees from across the site come, and it's an emphasis on safety, but I tell you, I'm not shameless. It's a good opportunity for me to get out in front of employees and find out, you know, do you have any artifacts? We're pretty proud of this, believe it or not, and I know Juanita wanted to get it out of our grasp. We have Savannah River Site Jeopardy. And if you think you know everything about the Savannah River site, let me tell you, I got a team that'll dig up stuff you never thought about. So we've got a couple of engineers out of F area, and they always come back and try to challenge us. Or I had one VP that came through, he goes, Susie, that's not true. And I'm like, ooh, yeah, you're not right, sir. It is, it is true. So you got to be careful with that. But yeah, historic Jeopardy, I don't know. Maybe we'll figure if we can work it in to see how well your knowledge is coming along with the Savannah River site. But last but not least, we talked a little bit about the Savannah River site history. How many of you in this room have been to the Savannah River Site Museum? A couple of hands. All right, looking thin over here. This is my invitation to you to go and see it. It is off the chain incredible. We started out with 75 artifacts, and I'm here to tell you, if we could have gotten a bigger building, it is phenomenal. We probably could have gotten all done. What does the Savannah River site do? What is the culture? What is the history? We are a small museum in downtown Aiken. It used to be the old Dibble Library, and I'm here to tell you, we've used every crack, crevice, ceiling, floor, you name it. I need a bigger museum, but it truly, take the time, open Wednesday through Saturdays, 10 to 4. You want to know what a waste tank looks like. You want to know how a reactor operates. You want to know how big. We've got the Forest Service. We have it all. Why is that important? Because you have to tell the folks in this community what we do. It is great for new employees. One Friday I came in and one of the parents came up and said, "You work at the Savannah River site. Tell me what my son's going to be doing." And it's just a way that you can come and see and learn for yourself. And then, of course, our Savannah River Life magazine. How many of you guys seen that? You have, sir. Okay, great. I gave Mr. Deshawn my copy. It is on our museum's website. We did not do a historical book this time. We decided to be more user-friendly. Number 2, Riding the Wave, is going to be on my desk this week. And I will tell you, we do a different approach. We don't talk about processes. We don't talk about equipment. We talk about the most important thing, and what would that be? The people. Exactly, the people. We talk about our early founding pioneers. We talk a little bit at what it looked like when, all of a sudden all these DuPonters showed up in our communities. And then Riding the Wave will be the next group of folks that talks a little bit about how they grew their families and their careers and things of that nature. Education outreach and is big for our museum. We have a specialist. She's a teacher by trade, does a great job for us. Kelly does, Galvarino. Our nuclear merit badge. This is huge. We actually have Jim Stafford. He used to be a RADCON manager, and several of our retirees help scouts get their nuclear merit badge, and it's one of the few in the country where you can come and get that. So we're really excited about that. The retiree legacy keepers. Our retirees know our history best. All of our docents in the museum are retirees. Who better than to tell the story? So, but that doesn't mean we stop there. We're always looking for new talent. So that's a way to kind of, and that's a way to find out how to get a new artifact, things of that nature. And then the Fall Vision Festival. I'm here to tell you, if you're in downtown Aiken on a Saturday, I apologize, I don't have the dates with me in October. We have kids coming into that museum. We have the mad scientist. Kelly and her team dresses up. It's a great little fall festival, but it's a great way to get kids involved in STEM. Why would we want to do that? We're looking for that next generation of workers, aren't we? So yeah, so we try to get them at every angle. And then our traveling new exhibit for the museum just left North Augusta. It is at the Aiken County Museum, and it's really, really neat. So I will tell you, we are very busy in historic preservation. I invite you to come see what we're doing. And he's got my phone number too. But in the meantime, any questions before we wrap up? I know I'm in front of lunch, but I appreciate your time, and especially our new members of the CAB. I know you're drinking from a fire hose, but we're here to offer any help if you need us. Okay?
Any questions or comments from around the table?
Okay. Well, thank you very much. Enjoy lunch.
All right, folks, before you leave, Juanita's handing out ballots for vice chair. I need board members, cast your ballots for vice chairs. As soon as she's done handing those out, she's going to walk back around and pick them up from you, so fill those out now. While you're done with that, before you leave, also, go ahead and sign your travel vouchers so that we can get those collected and get your travel reimbursement done. Turn the travel vouchers into Stephanie. So Juanita's going to go back around. She's going to start picking up ballots from folks, and I have right on 12 o'clock, so why don't we still come back at 1:30 and we'll get going there. If you've turned in your ballot and your travel voucher, you're free to go to lunch. Everybody will see you at 1:30 p.m. Thank you. Everybody, are we ready to get started again? Any questions, comments, concerns before we get rolling into our next set of presentations? Seeing none. Heather, you ready? Come on up. All right.
Okay, thank you. All right, well, good afternoon, everybody. I am Heather Cathcart. Like I mentioned earlier, I work at South Carolina Department of Environmental Services as Federal Remediation Coordinator, and I'm here to present an overview on the state regulatory oversight of Savannah River site within South Carolina Department of Environmental Services. So just a little bit of information about DES. We were established in 2024. We just celebrated our 2nd anniversary as a state cabinet agency. So we were previously known as Department of Environmental Control, and we were split into 2 standalone agencies, Department of Public Health and then DES. And we're headquartered in Columbia with 12 regional offices throughout the state. We have more than 1,200 team members, providing environmental oversight and essential services that protect all communities across the state. So we have 5 environmental bureaus within DES: Air, Water, Land and Waste Management, which is the bureau I work in, Regional and Laboratory Services, and Coastal Management. And all of our bureaus, except for Coastal Management, interact with SRS. So we are a team of environmental subject matters whose work impacts South Carolinians every day. We use science and data to drive our decisions and actions. Our work supports a resilient and sustainable South Carolina, and our efforts safeguard our air, land, water, and coast for generations to come. At SRS, we safeguard these natural resources through our permitting, cleanup, ESOP program, and emergency preparedness programs. So, EPA delegated the state authority for air, water, waste, and cleanup programs. DES protects human health and the environment through enforcement of federal and state laws, but however, we do not regulate the storage of, it says spent nuclear fuel, but I understand now it's used nuclear fuel or nuclear materials. So, South Carolina DES issues permits to SRS in accordance with federal and state requirements. Most of these permits will have a 30-day public comment period before the permit is issued or renewed. Once issued, SRS must meet the monitoring and reporting requirements of the permit. Then SCDS conducts routine inspections to ensure that they are still in compliance. These inspections are handled through staff through both our regional office and our central office. SCDS can take enforcement actions if necessary if the site is found to be out of compliance. So we have a variety of programs that issue permits to SRS. Some of the larger site permits are the National Pollutant Discharge Elimination System, or NPDES permit, the Title V Air permit, the Resource Conservation RCRA permit, and there are several smaller area Pacific permits that are issued for various localized activities at the site. These site specifics are like the solid waste permits for landfills and the underground injection control permits, which are issued as part of the cleanup efforts. Excuse me. So, under the RCRA hazardous waste permit, which I mentioned earlier this morning, SRS must comply with the requirements for management and storage of hazardous waste and mixed waste. Mixed waste is a mixture of hazardous and low-level waste. The RCRA permit also requires SRS to assess and clean up all waste-contaminated areas of the site, and the post-closure modules of the permit address the monitoring and corrective action requirements of contaminated areas. Another activity covered under the RCRA program is the site treatment plan. This plan was enabled by the Federal Facility Compliance Act in 1992, and it required DOE to devise a plan for developing treatment capacities and technologies to treat any mixed waste it stores or generates by an approved schedule, and it is enforced by an order. The STP covers legacy waste, low-level transuranic, and high-level waste. It also requires state approval for any hazardous radioactive waste shipment proposed to SRS. The site treatment plan was approved in consultation with EPA and the other states affected by the plan. So, the Savannah River site is a National Priorities List, or an NPL site. SEDS also oversees cleanup of the 515 waste units at SRS through the Federal Facility Agreement. The Federal Facility Agreement is a three-party agreement that was signed in 1993 by DOE, EPA, and our predecessor, DHEC. So it governs the investigation and remediation of the site, and it integrates the CERCLA, or Superfund, response action process with the corrective measures of the provisions of RCRA. So the FFA describes the roles and responsibilities of each party and the process by which the three parties work together. It also includes milestones which are updated annually and outlines the penalties for failure to meet these milestones in the dispute resolution process. We also developed the tried and true core team process, was developed by the three parties back in the early 90s. And this process is a formal, a consensus-based approach to decision making. We communicate frequently throughout the data collection and document writing process, which cuts down on the document revisions and keeps the project moving forward. This collaborative approach has made us one of the most successful programs within the DOE complex. We're very proud of that so far. One of the biggest environmental concerns at SRS is the high-level waste tanks. At SCDS, we have multiple program areas involved in tank cleanup activities. Section 3116 of the 2005 National Defense Authorization Act allows the Energy Secretary to determine, in consultation with the Nuclear Regulatory Commission, or NRC, that certain radioactive waste resulting from the reprocessing of used nuclear fuels is not high-level waste. Any residuals remaining must be under a state-approved closure plan or state-issued permit, and this work is covered by several permits. Okay. There are 51 high-level waste tanks split between F and H area tank farm. For 8 of these tank farms, waste has been removed and the tanks have been grouted up. There are still 16 non-compliant tanks remaining. They're considered non-compliant because they do not meet the secondary containment requirement. The high-level waste tanks are regulated by our Bureau of Water Industrial Wastewater Program, and they're operated through a wastewater permit, and closure of the tanks is conducted under a wastewater closure plan. SCDS approves activities associated with the waste removal, stabilization, and operational closure. There are also milestones for preliminary cease waste removal, which was mentioned earlier this morning, and operational closure in the FFA for the remaining 16 non-compliant tanks. These milestones were negotiated in 2022, and 8 of the 16 non-compliant tanks have achieved PCRW, or post-closure, preliminary cease waste removal. That means that all of the preliminary cease waste removal milestones have been achieved through 2027, which we will probably be doing 2 more. So we'll be able to say 10 by the end of the year. As tanks are closed and exit the wastewater permit, they are handled through the process outlined in the FFA. In addition to these tanks, South Carolina DES issues permits for several tank waste-related facilities: the Salt Waste Processing Facility, Defense Waste Processing Facility, the Salt Stone Disposal Facility, as well as the SDUs. So on to our regional office. SCDS oversees roles in the Environmental Surveillance and Oversight Program, or ESOP, that Madeline gives us excellent presentations on. So the ESOP monitors SRS and the surrounding areas to determine if there's any impact from SRS activities. The staff collects samples from air, water, soil, sediment, vegetation, milk, fish, and game animals. The results are reported in the annual data report and are released around the same time as the site's annual site environmental report, or the ACER. The most recent versions are available as the 2024 report, and you can find it on our websites. So, emergency preparedness. SCDS also has a role in emergency preparedness at the site, as South Carolina has a comprehensive emergency operations program for disasters in both natural and man-made, which includes the South Carolina Operational Radiological Emergency Response Plan and the South Carolina Site-Specific Plan. SCDS also maintains a 24/7 emergency response system to respond to incidents or releases. We take additional measures to prepare the potential emergencies at SRS. South Carolina DS provides technical assistance and necessary resources to respond to and evaluate radioactive material releases from SRS in collaboration with other state, federal, and local partners. And we provide protection, action remedies, recommendations to the governor and the state and local authorities responsible for public safety in the event of a release. SCDS also presents emergency response information such as basic radiation physics and established emergency response procedures to school and community groups around SRS. So this is our website if you need more information. It's dessc.gov, and then we also have our medias that you can go to, our Facebook page, Instagram, Twitter. I'm not sure what all of these are because I'm not that hip. So, do y'all have any questions?
We'll start with James.
Hi, Heather. Thank you. James Shack, CAB. From what I saw in your presentation, you have quite a bit of responsibility. Could you just give me an idea of what your footprint looks like from a manpower perspective on site?
Okay, so like I mentioned, we have 12 regional offices. Currently, SRS is in the Aiken Regional Office, so we have employees coming from that area that come to the site to monitor and our operable units and look at the activities going on, and they report that to the central office.
So now, they're not on site directly?
No, we do not have any employees directly on site, but we do have constant presence there. So either, like I mentioned earlier, the multiple areas covered by different permits. So like Bureau of Water covers the high-level waste tanks. Our solid waste group covers the SD saltstone disposal unit and the salt waste processing facility. So there is like multiple groups out of those areas at South Carolina DS that cover SRS. So, and then, my group with FFA, we're constantly on there to go do post-closure walk downs or even meet with the site if we need to.
Thank you.
You're welcome.
All right. Any other questions for around the table?
No questions?
All right, seeing none. Thank you very much, Heather. All right. And then next up, our other regulator, John, with EPA.
Thank you. Am I on? I guess I'm on. Yeah, I've given this talk. I try to give it at least once a year, like South Carolina. Also, when we do sometimes the treat in other places, I'll do it as well, because it kind of explains for those of you, especially new, why is EPA involved at Savannah River? We have sometimes similar roles in South Carolina, but sometimes different roles. This is kind of our big, I guess, our slogan. So again, we are working with Department of Energy as they are the lead agency in South Carolina as a regulator to get SRS cleaned up. That's really why we're here. Yeah, but we're the federal regulator over the cleanup of hazardous waste sites. So again, I think some of you know the overview of Savannah River, but I always conclude this in the slides. It's a little bit outdated, but it kind of shows you how far back we started doing things, I guess, officially with Superfund. And actually, you see in 1985, the state RCRA, that's the hazardous waste part that's usually delegated to most states, not all, but South Carolina had the delegation. So they actually were already starting to address some of the groundwater and other issues in 1985, because you see the NPL, I'll get to all that definition, but that's when you're officially listed as a Superfund site. And that was in 1989. And then, as you've heard earlier, the FFA, that's the Federal Facility Agreement. That's how we actually agree, that would be in this case DOE, in this case South Carolina and EPA, to address all the waste at the site and how the best to clean it up. So obviously a very large site, you see how many waste units, and if you heard me say earlier in my talk, 99, really over 99 operable units. Our software that handles all this only goes to 99. So our predecessor had to be more creative but just to give you an idea, a typical Superfund site might be, like a building half this size. Let's say it's an old building that had groundwater issues. That might be one operable unit. The building is contaminated. It might be 2, and maybe the soil is contaminated. So that's a typical Superfund site. It's maybe 3 operable units or 2. So the fact we have obviously a huge site here, and this is not unusual for DOE sites or military sites to have a large number of operable units. Yeah, so we're talking about a facility this big, and we kind of do the same thing with Oak Ridge. We kind of look at it as a watershed. So I don't know if you've seen different pictures of the site, but all the different streams that kind of feed either to the Savannah River, and all of these have had some kind of cleanups before. They're usually around some of the facilities we're dealing with. This is one of the ones I've done the talk on before, added to this, where I think it was kind of more recent, it's 2022, where we had addressed this part, some cleanup and controls back in the 90s, and then this middle part where, again, the public's not allowed on the property, and now the upper part has been done as well. But again, when you kind of see the watersheds, you kind of know really better picture of what you're trying to deal with, especially for past releases. Yeah, this is just showing the different areas that you may be familiar with and how far apart some of these are, especially the reactors, the central area. D is one of the big active sites that Brianna works on that used to have a lot of the coal production, I think deuterium and tritium stuff going on. So we have a lot of active cleanup going on there. Yeah, and so it's not just me, or as I said, again, normally a Superfund site with 2 or 3 operable units is one project manager. They might still have a lot of support with them, but in this case, there's 3 of us. There's been up to 6 at any one time. Oak Ridge has about 6 now because they have a lot more kind of decommissioning going on and demolition. We have a contractor that does a lot of our technical support, and we usually have a community involvement coordinator that sometimes comes to these meetings or sometimes helps set up other meetings. And then we also have experts. I've always been, before I became a project manager, I was radiation support to sites like Savannah River and Oak Ridge and any other nuclear site. So and we have an attorney that reviews all the regulations, and I'll get to some of that in a little bit, and a hydro and risk assessor expert. So again, almost any Superfund site, small or big, is going to have a lot of experts behind, because obviously the project manager, I might have expertise in geology, or maybe chemistry was my degree, but obviously I'm not a hydro or know a lot of chemistry. So this is what I kind of go through. I'll be introducing EPA, a little bit about how Superfund got started, how it got applied to SRS, and then how we get involved in the cleanup of SRS and the remediation. So sorry if I'm blocking some of you back here. So you see kind of the general idea of what we're doing, but really the second one is kind of a key thing. So yeah, we started way back in the Nixon administration in 1970, but often people think we're the ones creating the Clean Air Act, Clean Water Act, CERCLA, which is Superfund. No, actually Congress writes those, and we're the ones that have to implement them because they're environmental programs. So, but we have to write the regulations to implement those, right? And we have to enforce those, and we set the national standards, like drinking water standards. And then like most federal agencies, not usually like a DOE sites, because they're based on where their field sites are, but most federal agencies are 10 locations. So in Atlanta, it's not just EPA, it's labor, other federal agencies there as well. Yeah, this is what I mentioned before. So yeah, so CERCLA, rigorous hazardous material. We don't really do much with oil pollution. Safe Drinking Water Act, that would be like Drinking Water, Clean Water Act, Clean Air Act. So again, we don't create them, but we now, because they've been passed by Congress, we have to make regulations, and that can take a long time. So CERCLA started way back in 1980, and then it was amended in 1986. Well, I think during those 6 years, you're trying to figure out, okay, how do we actually do this Superfund? So in 86, when there's some of those amendments, that's when they kind of got to maybe some of the more practical ways to implement this. Because how did it get started? It was kind of like a reactive law. We knew we had a lot of these very contaminated sites that were usually bankrupt. And that's some of the famous ones were Love Canal, Valley of the Drums, which one of my colleagues started working on 10 years ago when it was done, and found more drums, even though that was a big success story back in the 80s and 90s. But we provide the authority for the federal government to respond to releases or threaten releases. So usually, we have obviously a lot of past releases, but obviously something happens like a train wreck and it's chemicals. That happened, because that was over 10 years ago, Graniteville. So our on-scene coordinators were there on the scene coordinating the cleanup with whatever the state emergency response were. So we get involved in all those. So what's the National Contingency Plan? Well, that's, we know again, for this case, CERCLA, Superfund, the easy way to say all that. You have to have some kind of regulations with the rules, and that's what the NCP does. So how to conduct CERCLA response actions, establishes a risk level. So we never had, okay, what determines something that we need to be cleaned up? Well, that turns out that's different for like a state than it might be for EPA. So way back in around the early 80s, it was 1 in 10,000 risk to 1 in a million risk. It's kind of in general, whether it be residential, industrial, let's say a recreational area. That would kind of be the general, but we usually don't prompt or take action unless we got some kind of risk of a chemical, a radionuclide that's over 10 to minus fourth risk, 1 in 10,000 risk. And like for residential, that means it's got to be within 26 years. I think industrial is about the same. But for example, a lot of our decisions here are actually based on South Carolina, because they have when something's over 1 in a million risk, 10 to minus 6, that prompts some kind of action. It might just be land use controls, something like that, but they have an earlier threshold than actually we do. And that's not uncommon with a lot of the states. So again, so we doing CERCLA, obviously we have all these private sites going bankrupt, had to be cleaned up, but they also knew a lot of the big federal facilities, military sites, DOE sites, had lots of old contamination. So, most of the stuff we deal with at Department of Energy, Savannah River, Oak Ridge, stuff that didn't have the best practices in the 50s and 60s. It's pretty rare we're addressing a site that had new contamination, in 1990. It's usually something way before that. But it delegates to DOE, DOW, the responsibility to implement CERCLA, so that makes them the lead agency. So again, we're still the lead agency if it's if we know it's a company and we have a name in the company, even if they're bankrupt, that's kind of like the responsible party if you can find another part of the company that can help pay for that. But that's not really the case for a federal facility. But they must still follow all the policies, procedures of the National Contingency Plan. But EPA being the lead again for CERCLA, we have to concur with that remedy by the lead agency or pick another one. And that's where we've been very successful in Savannah River, and that's not always happened at all DOE sites or all military sites. But as I'll talk about later, we have a core team process, at least since 2000, where we don't get to a certain level where, oh, wait, the state still doesn't agree with what we're cleaning up the groundwater to, or EPA. No, we don't get to those levels until we've reached some kind of collaboration or agreements. Yeah, so the federal facilities are subject to CERCLA, just like the private places. And then we also had to address, because not every, like Clean Water Act, TSCA, which is like PCBs, they don't address radionuclides. In fact, they exclude them unless they're from the Atomic Energy Acts. But because CERCLA pulled in the Clean Air Act that already declared that also radionuclides are also hazardous substances, that was actually pulled in for for CERCLA. So Clean Air Act was 1976. That kind of helped CERCLA say, well, yeah, radiation is also hazardous, even though it's kind of a separate category. But you'll see how we actually, in EPA, we can still treat it very similar ways as we do chemical risk. That was just an idea of how many sites we have across our region. Again, over 1,300 nationwide. And you'll see in a minute how many big radiation sites we have, which is not that many. So again, when we have a term called construction complete, like I have a site in Kentucky, it's like an old radiation, just where they used to take a lot of radiation waste, like Barnwell still does. And it was closed in the 70s, they had bad practices, and but it's now construction complete. It has a final cover, but it'll be monitored forever with like 5-year reviews because we have waste left in place. But anyway, some of these sites have been cleaned up, some are still ongoing. Yeah, just a couple of slides addressing what I was just getting into. So yeah, of all these total number of Superfund sites, there's not that many that have radiation, but unfortunately some of those are the big ones. Savannah River, Hanford, Idaho, some of the military sites. So how best to address radiation? Are we going to do it similar to chemicals? And in most cases you can. Because at the end of the day, we're addressing the chance of getting cancer. And that's the same for a chemical carcinogen as radiation is all carcinogens. So that's why it fits easy with the Superfund framework, fatal cancer risk being the same type of number, even if you started with a different chemical radionuclide. And yes, we kind of think it takes some of the mystery out of radiation. It's not, you know, when you have the same risk of 10 to minus 3 from plutonium, and you have risk from arsenic at 10 minus 3, what's worse? They're the same. Obviously, people think plutonium may be worse than arsenic, but if your cancer risks are exactly the same risk, they're both equally bad. So why does radiation fit this well? Well, okay, the primary effect from radionuclides is cancer. All radiation is carcinogen. Uranium is really the only exception. Yes, the radiation properties are obviously cancer, but uranium is one of the unique ones because it's kind of a very large but low, so we call specific activity. It's actually the chemical toxicity to the kidney that's a higher risk than the radiation from the uranium. So especially if you're inhaling uranium or ingesting, the toxicity is actually worse than radiation. But yeah, people ingest, inhale, eat same amount of contaminated dust and food, whether it's a chemical or rad, your body doesn't know the difference. And because normally a radionuclide, let's say like strontium, 90, that's radioactive. It's going to behave the same way as strontium and everything else in that. And if you know the periodic chart, strontium is going to behave the same way as calcium. Radium, it's going to go to the bone, like if you ingest it. It'll behave in the environment the same way. Yeah, inorganic elements move the same way through the subsurface of the body, whether they're radioactive or not. So yeah, when we're doing groundwater modeling and we have the 3 radionuclides and 3 heavy metals, we're going to know how they behave based on their inorganic characteristics, not the rad characteristics. So yeah, so when we get to cleanup levels, now again, this is true for all chemicals or rad. If you've heard the term ARARs, that's our fancy long acronym, applicable, which most things aren't, I'll give you a perfect example, or relevant appropriate regulations. So, drinking water limits, MCLs. There's many of those listed for chemicals and many are listed for radionuclides. They're federal regulations, all the states have adopted like the RAD MCLs, drinking water, exactly like the federal ones. And most states, in fact, I don't know if there's any state that hasn't declared that their groundwater is not a future drinking water source. So almost one of the most common things we have, whether it's a little private site somewhere in South Carolina or Alabama, or a big site like Savannah River, we're cleaning up trichloroethylene or cesium-137 to its MCL regardless of where it is. So it's not applicable, right? Drinking water it's not applicable because it's not a public water supply. Drinking water limits were meant for a public water supply. So what I was trying to say is the groundwater underneath the Savannah River site or a little private Superfund site, it's obviously not public water. Obviously, we don't want it to get to public water, but it's considered a future drinking water source, so it has to be cleaned up to the same way. Yeah, as I mentioned before, so carcinogens are at an increased cancer risk of 1 in a million to 1 in 10,000, where 1 in a million is kind of like a point of departure. So we often set some like preliminary remedial goals at 1 in a million, but normally, again, as I said, EPA wouldn't normally take action unless like arsenic or lead is over 10 minus 4. Now, non-carcinogens, which obviously there's a lot of those, uranium actually is one of those too. Again, its non-cancer properties are a higher risk than its cancer properties, the radiation. So that has different hazard index you may have heard of. Yeah, so the higher radiation global natural background is accounted for as well. Because there's one fact is, I mean, obviously we have backgrounds of arsenic all across different parts of, especially agriculture can be higher. But that's also true for a lot of natural radionuclides. Uranium, radium, thorium have just natural levels that are pretty consistent across the US and the planet, but they're usually can vary depending on the geology. And to give you an idea of our DOE sites, so yeah, our active sites are Savannah River, Paducah, Oak Ridge, that are all Superfund sites. Pinellas used to be one, or maybe it was just done under RCRA. That used to be where they used to make the tritium near Tampa or St. Petersburg. And now, of course, that's done at Savannah River with the new tritium facility here. So that was closed under a Florida hazardous waste program back, I guess, a long time ago. I have the dates there. So not every DOE site is a CERCLA site. So give you an example, Paducah is a gaseous diffusion plant that's shut down. Well, Portsmouth, Ohio was the exact sister site, and it's done under a state RCRA program. So some are under CERCLA, some are not. Usually the big ones are like Savannah River, Hanford, Oak Ridge, Idaho. Yeah, so it was added to the Superfund list in 1989, and again, required to have a federal facilities agreement. Again, that's with the state EPA. And again, that's a three-party agreement if you were before, and I had to apologize to Heather. This is the one part I left the DHAC name, but back in 93, it was DHAC, not DHAC, so she says I'm okay. Tell Susan it's okay. So you kind of see, yeah, so it covers investigation, remediation program, the roles and responsibility for each party, schedule the deadlines, which can be huge, enforceable milestones, penalties, procedures are working together. And again, as many sites get into, when you can't decide, dispute resolution process. So our role is oversight of remedial activities at Savannah River. Again, we're not the lead agency for DOE or military sites where we have oversight role, but we're ensuring that they're following all the CERCLA procedures, and more specifically, the FFA that reflects the specifics of CERCLA for Savannah River site. So that can be technical, procedures, information, guidance, training. And this is kind of gives you a typical example of these next couple of slides on what's investigation kind of comprehend. So obviously EPA is not doing this. Actually, DOE contractors are usually doing the investigation, either like many sites, because DOE has a long history, whether it's Savannah River, Oak Ridge. Many sites may have had some initial investigation like in the 70s or 80s, and maybe it wasn't determined to be a higher risk then, but now we're getting to it now because we do try to take care of the higher risk stuff first. So maybe now we're having to do some more sampling of water sediment to see if it's the same. Do we still need to do some kind of remediation, et cetera? And that's when we get together, how to clean up the site. That's our scoping meetings. We get together, DOE, the state, EPA. Yeah, just a little slide showing you, it's not just, it's obviously a simple cartoon, but even on a large DOE site, contamination can usually happen the same way where things leach. I mean, trichloroethylene is the perfect example. Here I am, a radiation expert, thinking can we work on all this radionuclide contamination at Savannah River site? And there is some, but it turns out TCE here, military sites especially, turns out to be one of the biggest hazards. It's a carcinogen, it's highly mobile, and then sometimes it's the big driver for a lot of things. We do even more than the rad. But again, the general ideas of how it gets into the groundwater and can be exposed to someone. So the state, EPA, our concurrence is required when we select the remedies, and that's what's officially called the record of decision. That's when it has to be signed by, in our case, our division director for Superfund. So a lot of decision documents are just signed by me or Brianne or our equivalents at the state, but when it's a bigger document like a 5-year review or a record decision, that's at a higher level. So again, implementing the remedies, operating them, determining that they're working okay. So yes, and that's when, especially since 2000, as we introduced the core team process at Savannah River, we started cooperating much better early in the process. I think one of the old practices of the 90s when CERCLA was kind of getting started at some of these big federal facilities, well, military DOE would just create all these documents showing all this contamination and just hope that we understand everything. And sometimes that was leading to very much longer meetings that needed to be had. So, yeah, so RPM, that's called a remedial project manager. That's what I and Brianne officially are, involved in the remedial process. And that's, in this case, via the core team and scoping. So we'll have scoping many times, not just one time. Maybe when we initially get some historical data and need to find out how much more data we need to really make a decision. That's often one of our first meetings. Yeah, conducting site visits, inspections, reviewing data, documents, that's a lot of what we do. And then commenting on those documents, resolving issues. So yeah, when we finally decide on, here's what we want to do with this site, like an A area, we may still have disagreements on the specifics of that. You may agree with the major part. So we'll have more scoping meetings, more resolution meetings, and we won't keep going with the site. In other words, DOE won't just continue on record decision without some kind of concurrence with us. That's actually what's led to a lot of breakdown and led to a lot of disputes at other federal facility sites, not just DOE, but military as well, where the lead agency just don't think they can get something resolved. There's no really kind of, unlike Savannah River and other sites, where they really make an effort to make sure we come to some kind of collaboration. And yes, our headquarters, so they get involved in proposed remedies. We actually have to, especially record decision or proposed plan that's kind of showing what's happening. Like Brianne's about to do one for our division director and kind of our peer review group in our region, which is made up of attorneys, managers, and experts of other Superfund sites that may not be federal facilities. So they kind of all weigh in on what we're proposing to do, like in her case, like L or A area or D area. Yeah, and always one of the big questions, is the state agreeing with you? Well, again, we don't move on until we have agreement with all three parties. That's not always true at all the sites. You might have, many times they get to that meeting, well, the state doesn't really agree what we're doing, but we're very, very glad and lucky in Savannah River, especially since 2000 when we implemented the core team process, that almost never happens or we don't move forward. Yeah, so that's when we give approval to proceed proposed plan, because that's what's going to go to the public, as I mentioned before. That's where the public gets the comment before we come out with a record decision. Okay, we're going to clean up this groundwater to this level, and we're all in agreement, but maybe the public wants us to do more. Okay. So the proposed plan, as I mentioned, that's issued to the public by the lead agency, in this case, obviously DOE. Obviously, we've had approval. So we're actually reviewing a draft now. And that's what she's going to present to our division director on making sure we're weighing all the options before we submit our comments. And then DOE will get our comments, the state comments. We'll have a resolution meeting if we're not agreeing with their answers. Well, that's happened many times. Before we get to the next part, which is the big one, because once we write the record decision, we've considered the public comments. We've considered all of our experts, our attorney comments. And then DOE will sign that record decision, state, and then EPA is really the final signature. So, yeah, so we're trying to ensure that remedy is designed and constructed according to the plan that we all agree to, achieves the objectives. There's something called remedial objectives that, whether it's, so it's usually labeling the contaminant, and it's going to get to this groundwater level, to get to this drinking water level by a certain time. That's kind of an easy example. But also to make sure that happens when we're leaving any kind of waste in place, that's regular monitoring. So a lot of the documents we're reviewing from the Savannah River are ongoing monitoring reports of trends in their groundwater, for example, at different areas of the site. And then what's really unique to Superfund, I've actually given international talks on this that they've been really interested, because when you're leaving waste in place, and you say you're going to monitor this, what's to make sure you keep doing that? Well, obviously, we'll have a little more assurance with a federal agency like a military or DOE, but it helps in making sure, because right now my site in Kentucky I mentioned, we're on the 8th 5-year review. And so not much happens between those, which is good. But what about 50 years from now? So we got to keep going. It doesn't stop at year 35 or something. Because in case of especially a lot of radiation sites, maybe that's a little different than chemicals, sometimes the radiation may have longer half-lives. It's going to be there for a long time. So Savannah River can never leave their site. They got lots of old radionuclides here. Yeah, so our EPA management headquarters get involved in the findings and follow-up. So the 5-year review is a huge thing. Yeah, and it's indefinite for most DOE sites and most military sites, again, where you've left waste in place. So we say the decision documents belong to all of us, not just the lead agency, and certainly the state and EPA, we're all part of that. And we must sign it for it to be final officially by the CERCLA requirements. So again, this is what, again, since 2000, I'll speak of it lightly, Brianna and I are about to present to our other, kind of have a mini EPA meeting. We have a big one for all project managers, but we have every 2 years, usually, we have one that's just for project managers that are over radiation sites like DOE or mining sites. So we're going to do a talk on the Savannah River Core team that I've given before at the bigger meeting, and Matthew's predecessor, Susan, and my predecessor have done that talks at other big, like the Waste Management Symposium in Phoenix. It's all describing our core team process, the scoping meetings, which is core team, and contractors are experts. But that, again, that bottom, it seems like simple to say, but that's where it usually breaks down at other sites, because one of the agencies, maybe it's the state, maybe it's EPA, maybe it's DOE, is not fully dedicated and committed. You know, they constantly just say, no, we're going to dispute. So we've had many sites. We have to go to headquarters with the political appointees that don't know any of the technical facts, trying to figure something out. And we could have just kept going with our scoping meetings until we came to some kind of collaboration. I give example of P area. It's one of the reactors that was shut down completely, but like a lot of those reactors that have other seepage space and other thing that had to be cleaned up. And we had some groundwater that needed to be cleaned up. And 6 years ago, we had all these scoping meetings. One of my other colleagues is now on another site. She really wanted the more effective treatment. I think DOE only had the money to do this initial treatment. And I think the state was with us. They really preferred the more effective treatment that was a little bit maybe more proven. But eventually, we could have had an impasse right there, but we didn't. We decided, let's go ahead and do the one we can do now. The DOE says they can implement now. And it's actually coming up around 5 years now where we'll determine, well, do we need to go to the bigger treatment? So that's a case where we could have broken down, not get anything done, kept going into disputes. But that's where I think the core team process can work. We would get collaboration, again, from our higher management down to our level. So just one of the final slides is all the stuff we get involved with. High-level waste tanks is kind of its own unique units. D area, one of Brianne's, not only it's got a lot of coash, it's also one of our PFAS, if you've heard that term. That's actually a lot more prevalent in military sites, but DOE sites have it too. But that's an example where I think Savannah River leads the way, because there's other DOE sites that are still not really wanting to sample for PFAS, because it has drinking water limits now. But we're actually moving along with D area. We've already proposed a record decision like in 2032, and probably gonna have to do some kind of remediation that's not all proven because it's such a new contaminant. But it turns out, I think Brookhaven Lab in New York has some kind of technology that seems to be working, so that just shows you all the different sites, usually what the main hazard are that we're dealing with. So not a hazard for CAB, just shows we get involved with the CAB. Yeah, we've been going since the 1980s. We'll continue probably 30 plus years when Brianne takes my job in 10 years from now or less. So yeah, it's not just radiation chemicals, there's other things too. Jobs require college degrees, jobs require high school diplomas, all require a clean record. So, and of course, some of our info there. Any questions?
Yeah, Pat, let's start.
Pat Kilroy, CAB. I've read several articles about that strontium-90 was one of the worst in the world because it affects children, because it's taken up like calcium. Is that true?
Well, because it was one of the big global fallouts, like Cesium-137, during all the atmospheric tests. So even though the U.S. stopped it in the 50s, Russia and China and others kept going with their atmospheric tests. So it's kind of spread all over the world because of its half-life, Cesium-137, because it's kind of the same 30 years. It may have gone through 3 half-lives since then, but it still can easily be found in most soil. Strontium-90 is a little more mobile, so it's a little harder to see, but yes, it goes to the bone. It's always a concern it gets to the teeth, like, you know, somebody ingest it. But obviously many studies have been done on, you know, being exposed to global fallout over the years. So it's not like it's a new thing. Oh, no, we got some, but, you know, like even here, Savannah River, I commented 2 decades ago where they kept claiming their Cesium-137 level was site-related. I said, or it was all the global fallout. I said, no, their numbers are slightly higher than the global fallout that we can see just going 2 counties away. So, but yeah, strontium-90 is one of those prevalent ones, whether it's, again, many studies have been done on, especially back 30, 40 years ago when it was a little more prevalent in the environment. So.
The other question I had, you mentioned PFAS.
Yes.
I think it's 3 or 4 years ago I read that the EPA, their limit was 3.5 parts per trillion.
I don't remember exactly, but we did come out with our drinking water limit, I think 2 years ago, and that's still in place. So we actually have a number to clean up to if we decide, like in D area, we're going to clean up the groundwater.
Well, I live in the Charleston area, and we have Charleston water. And I call the people, and they said our PFAS runs about 3 times that.
Well, that's a public water issue. I can't help you other than empathize with you. But unfortunately, PFAS, I think, is everywhere. We can only deal with it with our sites that we have ongoing, so, which is even more prevalent in military sites.
Do you think the government's going to come in and say, hey, clean up this stuff?
Well, public water supply, that's usually county, state, way before federal, but who knows? It's outside of my knowledge.
Thank you.
All right, Dell?
Dale Priester, cab. Can you guys hear me?
They should. Yeah, I think they got you.
Hear me? Hello?
Yeah, you.
Right. Thank you so much for your presentation. The question I have, you guys started going to the site in 1989?
Well, we got on the list in '89. I actually been going to the site before that for other things like NEPA. They were always doing something, environmental impacts stuff on new nuclear facilities, Savannah River, Oak Ridge. So I was getting involved in other ways. But yes, Superfund didn't really get going until '93.
Okay, so, and I know
but the state RCRA was already going, so they would already had people here way back before.
testing things. Okay, so that's kind of what I was wondering about. If the major testing thing didn't start until the 30 years after Savannah River site came, and now you've been there 30 years, do you feel pretty confident that there's a good cleanup taking place?
Yeah, if I understood you, yeah, they'd already done some of their own sampling because they're obviously trying to protect their own workers. And then maybe they didn't do enough to make sure, hey, do we need to clean this up? Because in the case of Savannah River, the main receptor is the future industrial worker because they're not planning to return over the site. Unlike Oak Ridge, like a third of Oak Ridge is now a commercial, 70 different companies that may not even be radiation. So that's a little more restrictive industrial, still not residential, which is usually the most restrictive. So Savannah River has done many of their own samples. They may have identified some of the groundwater issues that led to the state RCRA saying, okay, we got to put this under regulation, or maybe that prompted it, who knows. So it's not some of these areas were unknown when cesium got all over the site because of its tendency to just migrate downstream and just adhere to any vegetation, or that's why it's under all the streams. Whenever cesium goes somewhere, it just sticks there. We know that from Chernobyl and Fukushima now. So yeah, maybe we have some historical samples I mentioned that might have been done, let's say in the 80s before CERCLA or early 90s. Hey, let's check this area out. No, it's not as high as this area. But sometimes we don't come back to it because maybe it wasn't that high contamination. But now we see, well, yeah, still enough that we need to do some kind of groundwater remediation now that maybe wasn't as higher priority back in the 90s, for example. So yeah, I think we've done a good job with all those units, especially assessing as every DOE site and military site was doing, trying to assess the ones that might get to the public first. Like Paducah, they had TCE and technetium 99 and radionuclide going off in the surface water above the drinking water levels where there was people still on private wells. That was a high, high priority. We're lucky that never happened here. But at one point, we had a concern with the fish in the Savannah River that had some more significant strontium-90 and cesium. And so like a subsistence fisherman, this is like right when the reactors were getting turned off in the late 80s and 90s, they were a little more significant than what DOE was telling us. And we had data from Georgia and I think South Carolina kind of showing it's a little bit higher than they thought. And that got lucky because the reactor shut down, those levels went down in the fish eventually. But at that time, there wasn't maybe a concern for like your recreational fishermen, but a subsistence fisherman might eat too much fish and get too much strontium-90 or cesium, so.
Okay. Deborah.
Deborah Creech. Deborah Creech, CAB Chair. On your presentation under the National Contingency Plan,
yeah.
It has on one of the bullet points, establish the risk level that triggers cleanup action.
Yeah, that's what I mentioned, the 1 in 10,000, the 1 in a million.
And so that's that level that triggers it?
Yes, so we address this site. Let's say even an old site, we may have had some historical levels. We might assess it now. Let's say it's arsenic and uranium, and it's 10 to the minus 5. Okay, it's not over 10 to minus 4. It's not going to prompt us to take action for EPA, but the state's going to say, well, it's over 10 to minus 6. We don't necessarily need you to excavate it, but we need to at least put it in land use controls or something. And that's happened a lot. A lot of coash is kind of like that. Coash is not usually over 10 minus 4th, 1 in 10,000 risk, the metals and the rad. It's usually slightly below that, but it's definitely in the high 10 to minus 5 risk. So it's over 10 to minus 6. So sometimes we'll have a whole record decision to address like coash to make sure we have proper land use controls so like an on-site worker doesn't get more exposure to even arsenic or lead, the normal things in coash.
Okay, and does that confirm the reason you bring in your teams?
Right, and especially for any new site, we call our own scene coordinators. Let's say it doesn't have to be a train wreck, it might be a building that all of a sudden we discover got abandoned and nobody bothered to tell the community. And so we're trying to assess, do we need to clean this up? It looks bad, but unless that risk is over 10 to minus 4, something coming out of that building, like something in the water or air, then maybe it's this very bad building that needs a sanitary cleanup. But that's what they're using to justify, yep, we got definitely a chemical here that's 10 to minus 3. We got to bring in removal right now, and then it might turn into a Superfund site if it's a longer term cleanup. But in the case of a Superfund site like this, we've already kind of addressed historically and currently, so it's usually not a lot of unknowns for us. So.
Okay, thank you.
All right, any other questions for John from around the table? Seeing none, thank you, John. All right, before we move on, I'm going to ask, do y'all need a break? Yeah, all right, let's be back at, what time is it? 2:45? We'll take 10 minutes, come back. All right, folks, that's the end of the 7th inning stretch. Let's get into the end now. We got one more presentation, a little bit of board business to take care of, and then we'll be done for the day. How's that sound? Yeah, we're doing good, right? All right. So up next is archaeology. We promised you some historic discussions today. The first half was this morning before lunch. That was 1950 to present day. But he's got another 10,000 years before that he's going to talk about. Settle in, and it's going to be great.
Thank you very much for having me. How's everybody doing today? What was this, 1994, I believe, is when CAB started? That's just for a history note. And I think I've been doing these presentations probably since 1994, close to it. So anybody else been on CAB or been part of it since 1994? All right, so that means I can say whatever I want, and y'all not gonna, no. All right, so again, my name is George Wingard. Buddy, you're more than welcome to call me Buddy. I am with the Savannah River Archaeological Research Program, and we do not do dinosaurs. Just want to make that clear. Now, that being said, across the river at Plant Vogel, some years ago, they found the Georgiacetus vogelensis. It's a 40-million-year-old whale they found over there. So every now and then, when I'd reach out to my former DOE STR or my current NNSA, I talk a little bit. I say, it's about budget time, ain't it? And they'll bring up, have you found me a dinosaur yet? And unfortunately, we haven't. Hopefully, one day we will find one of the dinosaurs. But as of now, we don't necessarily do dinosaurs. But we do 13,000 years of history. Paleo people, the archaic people, the woodland people, Mississippian people. These are all Native American cultures. And I'm going to answer this question first. For anybody answers it later, there was no contact. We have found no evidence of contact period Native Americans on site. Cherokee was north of us. Seminole well south of us. We had the Westos to Chickasee, the Yamasee all around us, but we have found no contact period Native Americans on site. So I just want to answer that question now, because I know usually I'll do this too, and I'll go, hey, was there any Cherokee out there? No. Nobody. Around 1500 or so, it looks like the Mississippian period kind of petered out. And then the next thing we start getting into is the colonial period and whatnot. So, so there a little bit about that. And I'll probably touch base a little bit more about that. But Savannah River, excuse me, which side do I need to stand on here? I like to wander. So Savannah River Archaeological Research Program is a division of the South Carolina Institute of Archaeology and Anthropology, which is a department at the University of South Carolina. We have been an on-site presence on-site since the early 1970s. We were invited to come on site to do intensive watershed surveys. Upper Three Runs, Lower Three Runs, Steel Creek, 4 Mile, and Penn Branch. Those are our major drainages that come through the site. They branch off. That's going to be a very high level probability for Native American culture. So in 1973, we were invited to come on. In 1978, we became a full-time on-site presence. So we've been on site over 50 years in one capacity. Our program started 48 years ago. So we've been on site for a while. We weren't there in the 1950s because there was no call for us to be there. Which button here is this one? Here we go. What is archaeology? Archaeology is scientific study of people from the past through the things they made and used. We got 2.5 million artifacts in our curation facility. As a result of federal and state laws, regulations, the South Carolina Archaeology Anthropology, we began phased approach in 1973, as I just stated. Intensive surveys, data recovery, coordination with major land users on and around the Savannah River site. The Antiquities Act of 1906, Section 3, subsequent cultural resource laws, regulations state the intent of Congress that we have to be on site. Now, this is Executive Order 11593. By a very controversial President Nixon. But we like President Nixon because he is the one who said 11593 is going to protect cultural resources on federal property. And that is what we do. We both protect and manage the 13,000 years of history on site for for Department of Energy and NNSA now. We have a threefold mission. Cultural resource management, again, we have a crew, there's 10 of us on site. We are one of the direct contractors. We're up there with Centerra and the U.S. Forest Service. We're also a direct contractor like the Ecology Lab, whereas they have hundreds of people. There's 10 of us doing the job on site. We manage and protect those 13,000 years, everything up to 1950, which then we handed over to the Cold War. I believe you probably had Susie in here speaking this morning, right, about everything where they pick up from us. But we handle, all that. We go out and follow procedures. The site use procedure, which I'm going to talk about in just a moment. We're allowed research. Understanding what we do with these resources helps us better protect and manage. I mean, that's only, that goes hand in hand. I mean, if we can better understand what we're protecting, we're going to be able to do it faster. We're going to be able to do it cheaper. We're going to be able to get in and get out. As my former boss used to say, we do not want to be the long pole in the tent, meaning we don't want to hold anything up. We get out there, do what we need to do, ensuring the protection of those resources, but also working hand in hand with all of the contractors on site. Very rarely have we had anything that needed to do that we would impact. Every now and then a road may need to be tweaked a little bit, or a log deck. The U.S. Forest Service has log decks where they load their trucks. Every now and then one of those have had to be moved. But really nothing of consequence where we have had to really stop any production on site. We're pretty proud of that. Again, compliance. And the site use process, I'm going to explain that to you really quick. The way the site use process works, real simple. Every scope of work on site is initiated by basically like a little report. And that report, that contractor will send that report to all of the other contractors on site, us included. So for example, if the road crew on site was going to put a stop sign up at the end, maybe right out in front of 700 building, they were going to put a stop sign. Archaeology would say, hey, no problem. Go for it. We already know the road's probably wiped out anything. There's been 75 years of stuff going on. Put that there. But if they came back and said, we're going to put a monitoring well, for example, along upper 3 runs, that would initiate for us. We'd say, well, wait a minute. And we'd send that report back with a concur with comments. Basically, we would say, wait a minute. Let us go in and survey, because there's going to be a high probability for Native American cultural and artifacts in that area. So let us go in and do what we need to do. All the other contractors get the same thing. Ecology Lab may say, wait a minute, we've got a species of flower there we need to look at. Road crews are going to come back and say, hey, we concur with that. You're not putting a road in there, you're putting in a, so so we all work together. So the site use system is really the process on site that makes sure that all of us contractors work together in what we're doing on site, where everybody's at, and that we're not impeding each other's scopes of work. And we're able to do that since we're on site every day. I have like 6 or 8 site uses will come through my office every week. That I look at and then pass on to my crew, and we evaluate whether we need to go out at that time or is it something we concur on. Again, putting a stop sign up somewhere. Fulfilling the mission at work, a few photos here. Of course, some of our heavy equipment, transits, shovels, and we dig the square holes. You've all seen the Discovery Channel. That's our heavy equipment. Every now and then, maybe a machete if the U.S. Forest Service kind of gives us permission to take a machete out, but we're careful with those. So that's what we do every day. I mean, we're right out there working in the, and this is actually, well, actually, I forgot our third mission, public outreach. I forgot that one, public outreach. We also are able to go out and do public outreach, dissemination of the information that we find. We do this on a pretty regular basis where we come out and speaking to you all folks today. We do this on a pretty regular basis about what we're doing on site, some of the research we're doing, some of the projects we're working on. So this particular project, we were working in Graniteville for the day, helping them with a little project as part of our outreach. We were working there just for the day. Had a lot of kids come by also and watch what we do, so that's a lot of fun. Let them get dirty. Artifacts come out of the ground. Basically, this is our heavy shaking unit, handheld shakers. quarter-inch screen. What falls through the screen we don't keep. What stays in the screen we do keep. So for those of you who went to our curation facility a couple of weeks ago, in those boxes are 2.5 million artifacts. Mostly what's in those boxes are broken glass, rusty nails, chert flakes from stone tool making, things that are left over from when a Native American would have made a projectile point or an arrowhead, as most people call them, or a spear point. So, but we do have some neater artifacts in there also. But if it doesn't go through this screen, it comes back and it becomes property of NNSA, which we manage. I'm sure they're happy to hear they're managing some broken glass and whatnot. But daily field work, pedestrian or shovel test surveys to identify archaeological site. It could also involve large-scale excavation. So what my crew does out every day, the biggest land user on site that we work with every day is the U.S. Forest Service. They're cutting trees, they're planting trees, they're thinning trees, and these are acres and acres and acres of land that they're doing. And we know these prescriptions several years in advance. So we'll know through the site use process that they're going to work in a particular area. Gives us time to go in, do shovel test surveys. We start off in a grid pattern. We go every 30 meters. A negative shovel test tells us just as much as a positive shovel test. Negative shovel test tells us nobody was there. So if we get a positive shovel test, we keep working, and then we'll come back to those positives and come in on a closer interval scale to see if we can get an outline. So for example, if in a positive we may find, a coin. We have coins in our collection. We may find a Native American biface, or what most people call an arrowhead. We'll come back to that point, then we will work off of it and see if we can delineate, is this a whole site, or was this what we call an occurrence? Somebody just dropped a coin, we happened to find it, and it gave us an extra half days of work to figure out if there's more there. But if we did find something, then we kind of say, okay, we found a site here. There was a coin, there was a bottle top, there was a spigot, old spigot handle. So we may start saying this is part of a home site. So then we kind of, do our research. We can go back and look at old land plat records and whatnot to help us determine what we're looking at and have we found something. Native American the same way. If we can delineate it, we can come back and go, okay, who were these people? Were they paleo people? Were they woodland people? So. Oh, and this particular site here actually is on site. It's in the footprint of the Three Rivers landfill. We actually excavated this back in the late 90s because we knew at that point the Three Rivers landfill had picked this area as a spot for where the landfill was going to go, and eventually they did agree to this spot. So this site here was the George Bush, not our president, but it was an old home site dating to about the 1860s. And actually you could see two of the chimney piers we excavated and the footings here. So this would have been a two-story house sitting right there in the woods. It burned around 1900 or so. So we were able to come in and excavate the house, thousands of artifacts that we found. So again, careful excavation. Here what we're doing is we're actually excavating the fallen bricks off that brick pier you just saw in that photo. Here we're doing just some measuring. This is water screening. This is another off-site project we were doing for some kids and some research we were doing. And we were pumping the water up from the Savannah River to help us screen this muddy, thick clay that we had been digging through. And that's me about 30 years ago and about a lot less weight. We'll throw that out there. And that's me right there. And that's a good friend of mine who has since passed away. But yeah, screening, detailed mapping. So everything we do, now I will tell you these slides are a little bit dated because we do have some technology now that helps us do a little bit more than this. So detailed mapping, the gentleman you saw earlier with the transit, he would be shooting at this young lady here. We're getting elevations. Once everything comes out of the ground, it's lost. That's why if you're the best thing is to keep everything in the ground protected. If it's got to be excavated, you've got to do it to a point where you can recreate it at least on paper, if not the computer, because once it comes out of the ground, it's gone. And once, if there was not a process in place, for example, the George Bush site, if there was not a process in place, bulldozers could have come in, road crews could have come in, just plowed everything under. And again, that is federal property. So, under 11593 executive order and section 106, those areas have to be protected. And so that's, again, why we're there. So one of our larger screens. Ground penetrating radar, we now have 2 ground penetrating radars in our office, which we do get used on site quite a bit. We'll get phone calls since we have 2. We found water lines for folks on site. We have found electrical lines and things like that. So that's pretty neat. They'll call us to come out. Ground penetrating radar, well, we're working on, again, this is the day we were working in Graniteville. And what we're doing is we're running over a grave site. And what it shows you here is it runs across the ground. This is undisturbed ground. They've hit something. Undisturbed ground. They've hit something. They've hit something. So what we're running across as we were doing this were the grave shafts. Undisturbed ground is going to come up. It's going to show as kind of virgin soil. But once a hole was dug and the ground disturbed, so we were able to find the grave sites as we were going through for this particular project. We use this here on site also. We have 100, there were 100, wait a minute, let me get my numbers started. 6,000 people were displaced, 6,000 dead were moved. We had 135 cemeteries. To date, we have about 37 cemeteries still on site. Had to get my numbers straight there. 37 cemeteries still on site. About 700 individuals are still buried. So today we are using, both interns who come out and do work with us, our volunteers, and we're going out with our ground penetrating radar to better evaluate those cemeteries that are still left based on the maps that the Corps of Engineers drew out for us in 1950, which were really great maps. I mean, they did a good job. So, LIDAR, we don't have LIDAR, but LIDAR has been used in places on site. So we've been able to utilize some of the maps that they've created. Basically, LIDAR is GPR from an airplane. They can drive by, or they can fly by. Drive by. They fly by. They shoot a radar down into the ground, just like our GPR unit would do from the ground. Bounces back up, and they can see They can see colonial roads that had been, out here on site from 1800. And once it moves that tree layer level, you can see the roads as they were. One of the first times we used it, late in the early 2000s, and the map came back with all these strange little mole holes. So we were all looking at it. There's these little tiny, look like little ant holes just going into the ground all over the site. And it took us a little while to figure it out. Once we put all the pieces together, they were all actually bouncing off the bottom of open wells that had been dug, 1850s, 70s, 90s, 1900s, The LIDAR was going down into the well and bouncing back up and leaving a little spherical hole all over the site. So it took us a little bit of time till we kind of put that together. That's what they were finding. But really, really interesting history, interesting technology. And again, kind of shows you how they can see the trees. Once the artifacts come into the lab, they're washed, they're bagged, they're tagged. All of this is done in acid-free bags, acid-free tags, washed and cleaned. This is few pieces here, washing of some glass. Piece of what's called solarized glass that she's looking at here. What's interesting about solarized glass was we can look at this piece of glass and know that it was definitely not made after about 1917. Can anybody tell me why they might think this glass was not made after 1917? No? Okay. Up until 1917, the glass making procedures in the United States did utilize some portion of metal. Well, after 1917, metal was being used for World War I. So the glass we see here would have been clear, but in the sunshine, it became what we call solarized. It started to turn purple as the metal is reacting with the sunlight for so long. So we can actually look at that piece of glass and know at least it was made prior to 1917. And then we'd look for other marks to help us kind of go, okay, let's get this date a little tighter. But we wash everything. You can see here there's glass, there's ceramics, both prehistoric and historic ceramics, broken plates, broken cups, broken saucers, things like that. Civil War artillery button that we found. Kind of neat little button we found. One of our digs. Hammond, Turner, and Bates. They had a factory was in Birmingham, offices in Manchester, England. Produced many of the high-quality buttons for the Confederacy. So this was found way, way south of the site. We did not have any Civil War battles on the site. We did have trench works at the far south of the site and on the far east side of the site. Idea thinking maybe Sherman would come through. So these breastworks were built to kind of keep him. Of course, he went through Barnwell, went on through Aiken, and did not come west. Just a little story. The Battle of Aiken sent the Union troops to Columbia. So around 1895 or so, the mayor of Augusta said, yeah, they didn't come over here to Augusta. They took off and went to Columbia. Well, Sherman decided to write a letter to the mayor of Augusta and said, we can come back and finish the job if you need us to. So, yeah, a little history there. But clay marbles, kids, clay marbles. Anybody tell me what they think that is? You're going to be pretty close, but it's trigger from a gun, but it was actually a kid's gun. Roy Rogers, something to that effect. Those kids' guns, that's what this was, a little kid's gun trigger. And that's what's amazing about working on site. When you pull an artifact out of the ground, be it prehistoric, be it historic, for those few moments, you're reminded of what was lost. I mean, this kid lost his gun. These kids lost their marbles. Figuratively, literally, I don't know. But as I said earlier, compliance, research, we then begin to pull together this in reports. We go and speak, we go to conferences, we go to schools, we go to events like this. As I always say when I give my tour of the curation facility, we go to bachelorette parties if you invite us. Wherever you invite us to, we will go and talk about archaeology because we want the people to know about what we do. So we will go anywhere. Have food, we'll travel. That's what I say. So I got food here today, right? I got a candy bar. I did get a candy bar. So over the years, we've done some papers. We have a website, but also, we can get emails to you if you're so interested. Some of the books we've written, Old Farm, New Farm, about what was going on in the 1950s with the modernization of farms on site from early prehistoric, historic. These are both reports that really kind of tell you the overview of what was going on site. These are all as PDFs now. We printed these years ago. The government printing office used to print them for us, but now we can do everything digitally and just upload it as a PDF. We've scanned these older books. So there we go. Dedicated ensuring protection of our cultural resources, management, research, and education. Site use system, I explained that earlier. Land altering proposals could potentially destroy archaeological resources, so we all work together to ensure that hopefully that won't happen. Natural resources, cultural resources, roads, pipelines, electrical lines, all of that falls under what is protected by site uses. Timber compartment surveys. Again, U.S. Forest Service is really the biggest land user as far as what they do each year into thousands of acres, planting, thinning, cutting, and all that is detrimental not only to subsurface materials, cultural resources, but natural resources. Red-cockaded woodpecker. How many of you have heard of the red-cockaded woodpecker? That's the number one thing on site. That stops everything. Being a little facetious here, but not really. It is highly endangered. Ecology, U.S. Forest Service knows where those trees are. They only nest in dead trees. And so you see one, you turn away, and you skulk off into the woods and don't say nothing. And because they're highly, I mean, it's like I think we got more bald eagles on site that nest over on the west side than we do the red cockaded woodpecker. Curation, again, about 2.5 million artifacts have been analyzed since this slide. Some of these slides are kind of dated, but about 2.5 million artifacts. The site, again, 310 square miles, 200,000 acres, straddling Aiken, Barnwell, and Allendale counties. I mean, it's a big site. It's a really, really big site with a lot of history. A lot of history that all of us should be proud of. From local, a lot of interesting history out there. As I said earlier, we do on occasion work off-site, not because, for specifically, both historic and prehistoric, the occupations did not stop on just the modern day boundaries of the site. They went off. So by doing research off-site, doing outreach off-site, it better helps us to understand what was going on site. We don't do that a lot. I mean, compliance is our number one. It's what we do every day, but research on the occasion that we can. Some of our research on site, Carolina Bay research. These are early areas of kind of water retention kind of areas that date back thousands of years. The way the geology allowed for these to hold water, the Native Americans would come in and settle around them, you know, because animals would come to these areas, so they could settle, you know, along a side of it, and ducks would fly in, wild animals would come up, so they had everything they needed: water, the animals, in a nice, you know, place that they could settle, you know. Mississippian project, Mississippian period, was out on site AD 1000 to about 1600, 1550 or so. This is when your populations of Native Americans were so much larger. You know, the Paleo people were following the large fauna. Believe it or not, we had large ground sloth on site, the large bear in the area, saber-toothed tiger in the southeastern area. And then Archaic period, still mostly that, but starting to settle a little bit seasonal. Get to Woodland period, they are starting to have encampments where they're staying year-round, and they're starting to make pottery and things like that for storage of food, trade. And then you get to the Mississippian site, where there are now kingdoms. We don't know if there was any Mississippian mounds on SRS. We found no evidence of them. We do know of one. We know of two north of the site on either side of the Savannah River, and we know of two south of the site on either side of the river. Mound could be anywhere from just a few feet high to 90 feet tall, like the Etowah Mounds up near Atlanta. And the king would be there. The king or chief would be there. He would rule over population, sometimes 10,000 people. Palisaded walls around it for protection from other Native American tribes that may want to come in and attack. Trade would go on also, but occasionally you had clashes at times. We did a little bit of research over in Beach Island at the Bartley site. This was a colonial site, which really impacts some of the colonial sites we have. We have some colonial sites in the Cracker Neck area of the site. If you've seen a map of the site, I always say it looks like George Washington. So I don't think I have one up here, but you know, the lower three runs is Washington's little pigtail, and then he's got his nose. That's where Cracker Neck is on the western portion. A lot of colonial sites. Some of the earliest colonial people inhabited Cracker Neck. Catherine Brown site, one of the first female landowners, as well as she had a business. She had a cow pen. People would bring their cattle to her to be slaughtered, to her and the guys that worked for her. So she actually had an early female-owned business on site, Catherine Brown. And again, George Bush Plantation. Amassed considerable wealth and influence. This is the house, what we think the house, well, we know what the house would have looked like that would have sat there. not your grand kind of plantation you think about when you start talking about the antebellum period. He was more into property. It's what he was amassing for the Bush family. Community history projects. We've done a lot with the former communities. These books are online. A book about Ellington, Dunbarton, in a kind of a diary written by a gentleman that lived in Ellington, because Ellington, my hometown. These again are PDFs. We can get you links to download those. Again, 6,000 people were displaced. Ellington, Dunbarton, Myers Mill. Those were the larger communities, and of course a lot of other smaller hamlets around Hawthorne, Sleepy Hollow, Greenland, that were impacted by the move. So if you ever take one of the tours I give, I can certainly give you a lot more detail on those tours. We decided we were going to become Hollywood. We said, hey, we want to make a few movies, so let's start making a few movies. So we started doing that. Our first movie was Discovering Dave. Some of you may have had a chance to go to the curation facility when there. You may have seen the Dave jar that was in the case. Dave was an enslaved individual from Edgefield, born about 1800. He knew how to read and write. We don't really like to talk about Dave and his jars, their prices, but this is the only Dave jar found in an archaeological context that we have on site. And I've been honored to be able to speak about Dave for about 20 years now. So love telling his story and sharing his story with folks. Hawthorne, film about Hawthorne. Any of you from Barnwell? Over in Barnwell area? Anybody ever been through Barnwell? Okay. You've been to the area, stopped at the Little Red Barn? Little Red Barn. Did a film on the Little Red Barn. You know what the Little Red Barn was? The Little Red Barn was the commissary for the Lee Banana Case Company that was on site. It was moved from site, moved over to Barnwell. It had a long life before it became what it is today, the Little Barn Pottery, owned by Mr. and Mrs. Ringus. Mr. Ringus just passed away last week, but Miss Ringus still there. And a couple of other little films. I think we've done about 12 now, films. I told you it's a little bit dated. Volunteers and interns. We've had volunteers for years on site. Interns. We've got an intern now that is working to help survey the cemeteries. We've got an intern now who's helping to kind of go through some of the collections into a new database we're working on. We've got a couple of other volunteers who are working on some of the collections, helping to better analyze them and survey those. We actually have one volunteer. The program, as I said, has been around since about, it depends on the date, 73 or 78. Those are our two dates. We actually have a volunteer who's been with the program longer than any of us have been with the program. She started volunteering in like 1978 and still comes out. She's about 80 years old. She volunteers at the Riverbank Zoo. She has a couple of other places that she volunteers at, and then comes out every week and volunteers with us. So pretty amazing. But great, again, volunteers and interns. And we go out, we do exhibits, we do public tours, excavations, public dig opportunities when we can. Public tours, historic tours, we do in conjunction with SRS, both in October and March. So this October, we'll be doing 3 tours. It's a round trip kind of curation through the site, and we end up in Ellington. And then in March, we do the same thing, but we go through the site, we go to Dunbarton, and then we end up at curation. And on October 29th, we will be doing a longer walking tour of Ellington. So all those, you can go on site and sign up for those bus tours. Again, we did classroom digs. When we're requested, we kind of go out, teach archaeology in the classroom. And in 2018, we will be celebrating our 40th anniversary. So I can't wait for 2018. So I told you this was a little dated. 2018, we're going to be celebrating that 40th anniversary. So we're 48 years now, 48 to 53, depending again which 2 dates you want to look at. We were out there in 73, became a program in 78. So, and there's some of our links to some of our YouTube and the Facebook. If you're on the Facebook, you can go to Savannah River Archaeological Research Program. We do exhibits all over. We've got one in Aiken. We take them out. We have things that we can take out and visit if people so choose to invite us. As I said, all we need is food. Have food there. We'll be there. Any questions? Anything for me?
Yeah, we'll start with James. Go ahead.
Hi, James Shag, Cab. Thank you very much. That was very informative. Aside from that George Bush site, do you have any other permanent or long-term digs on the property?
Well, we have one bay, one of the bays we're working on is called Flamingo Bay. We've been working on that for years, off and on. Again, just focusing on that period would be the Native Americans. We're working on the George Bush site is one of the ones we're working on. Right now, the cemeteries are a big thing. We're going back and reevaluating and resurveying the cemeteries just so we can get better GIS data with those. Everybody on site has done an amazing job of protecting them. They know where they're at. There are data layers that people get close to them. On the maps it shows. But with the newer technology, we're doing more of that to kind of better enhance those cemeteries and using the GPR to find where the unmarked graves are, so we can get them.
Your strategy in those areas is to keep it in place, right?
Definitely. Anything, especially the graves particularly. Yes, right. Keep those in place. But as far as the Flamingo Bay, that's both compliance. Some work was going to go on around there, but it's also research because we've got, 100 plus bays on site, and every one of them has the potential for Native American. So the more we learn around this one bay, we can better anticipate. It seems like they always wanted to settle on the western edge of the bays. That seems to be what we're seeing. So, when we go do a bay now, we can kind of start, we circumvent it or go around it, I should say, and then focus on that western portion when we start finding the predominant artifacts. So yeah, but those are the main three things we're doing right now. So thank you, sir.
Thank you.
Okay. Dell
Priester, Cab. What I wanted to ask, some of the things you're finding, have found, like broken plates and things like that, you think it probably was left over when all those towns and the people got displaced?
Well, what used to happen back then was, you didn't have a lot of the preservatives in the food you have now. So what they would do is broken plates, things that were broken, they would sweep things to the edge of the property. So you would have like a slope or something, and that's where they threw most of the stuff. You didn't have a lot of the smells you would have because there were no preservatives. So they either ate everything, and what they didn't, they threw down and disappeared pretty quick. Broken plates, they would throw away, things like that. So who went out to the facility and saw the Dave jar? So a few folks saw the Dave jar. The Dave jar was actually broken. I put it back together. The difference with the Dave jar when we found it was in a hole, and it looks like it had been reverently buried. It had been broken. They didn't have Elmer's glue or whatever compound to put that jar back together to cause it to be workable again. So when they buried it, they kind of stacked it all on top of each other. So when we found it, it came out of the ground piece by piece. So there seemed to have been a reverence for that. But most of what we see, the broken glass, the broken things like that, edge of the yard thrown away, and as we're doing our shovel tests, we're hitting that broken glass. So a lot of times if we hit the transect just right, we'll go through a trash pile. So it's like, oh, I got a broken glass over here. Oh, I got a broken glass over here. So it's a whole day of going through broken glass. So, and that tells us a lot. I mean, it helps date the sites. So, yes.
Thank you.
Correct. Yeah, thank you. Any other questions?
Seeing none. Thank you so much.
Going twice, going 3 times.
Thank you much. All right, folks. We're a little late for it, but we'll go ahead and ask. Was there anybody who wanted to make a public comment? Okay. Due diligence. We're going to ask. All right, so up next is our board business. If you haven't opened your packets yet and looked at the very back on the right-hand side, do so now. You're going to pull out 2 documents. One of them looks like this. The other one looks like this. We're going to deal with this one with the staple in it first, okay? This is that chair's recommendation we were talking about. This got emailed out to you. Everybody's had a chance to read it and look at it. Deborah, I didn't know if you wanted to talk a little bit about the discussion that you all had in Hanford, or if you just wanted to let folks ask questions. How would you like to proceed?
Let them ask questions. They can.
All right, let's do it that way then. Did anybody have any questions about this chair's recommendation? Now, as a reminder, I mentioned this morning, we won't be able to wordsmith this any. We have to take it as it is. This was wordsmithed by the chairs and vice chairs of all the boards. The way these work is if you as a board vote in favor of it, the Savannah Riverside CAB's name will get appended to the end of it. These all go to EM1, Tim Walsh in DC for response at that level, okay? So this isn't a site one. We won't get a response from Edwin with Edwin's signature on it. You'll actually get one from DC, okay? James, I saw your card go up.
It's probably self-explanatory, but I just wondered, what is the main intent? What do we hope that Mr. Walsh is going to do with this information? Just it seems more informational than anything else.
So sometimes, and I'll let Deborah expand on this if she chooses, sometimes a recommendation is just that. It is, we like what you're doing, keep doing it. It doesn't always have to be a new initiative. Sometimes it's the endorsement of an initiative to encourage the department to take it farther, or do more with it, or at least stand behind it longer. So sometimes an initiative or a project or a program that's maybe just getting off the ground, just finding its legs, community support can help with that. And I think that that's kind of where this one lands. How do you?
And just to give you an update on what you said, at the bottom of the recommendation, it says the effort may ultimately reduce expenses to procure equipment and materials. The EM staff chairs recommended the DOE EM's effort to save taxpayer dollars through the integration of reuse and recycle community of practice. So what they were saying was they was very interested in making this recommendation to do the recycling that would save expenses, save, the budget, where we can really, really save taxpayer dollars. It's basically helping and support this recommendation. You're welcome.
All right. Any questions, comments, concerns about this? Do we feel that we have enough knowledge that we could vote on it today?
Mm-hmm. Yes.
Okay.
Yes.
Do we have a motion to vote?
Yes.
How about a second? All right. All those in favor, please raise your hands. 1, 2, 3, 4, 5, 6. Any opposed? 1 opposed. And I know we've counted everybody, but at due diligence, I'm going to ask any abstentions. No. Okay. The motion passes. Deborah, I don't think we've gotten your signature yet, so we're about to. All right. So that's that one. This next one is the budget priorities letter, or the integrated priority list. So we talked about this last month, right? We had a committee meeting online. The members in attendance did a little bit of wordsmithing on it, drafted this document. It's very much in line with what the CAB has sent to DOE in years past. So the intent of this one, again, is to put the board's priorities in order for budgetary reasons. This becomes community input into Savannah River's budget and goes to headquarters. Now, it doesn't mean that this is how things will get funded. It doesn't translate into the administration's priorities, but this does translate into what your priorities are and helps give context to why things are, the dollar amounts are assigned to things the way that they are, okay? I'll also add that dollar amounts don't necessarily confer importance. Some things are very expensive and important. Some things don't cost a lot but are very important. Spark plug in my lawnmower doesn't cost very much, but without it, mower no go, right? So let's keep that in mind as we go through. So this had some wordsmithing attached. This is something that we can continue to work on if there is board input, questions, comments, concerns about that. So anything from around the table in regards to this letter? Yes, sir.
I just noticed the draft.
Oh, can I get you in your microphone, please?
James Shack, Cap. I just noticed that the draft from April had that sentence at the end about the payment in lieu of taxes. I presume it was omitted because it's not an environmental impact?
It's not that it's not an environmental impact, it's that the PILT program, the payment in lieu of taxes program, is what they call a landlord function. And because that was in the letter in prior years, because PILT or EM was the landlord for Savannah Riverside, that's no longer the case. NNSA took over in the prior fiscal year. PILT moved over with them. It's now part of their budget process and not EM's. So it was removed for that reason.
Makes sense, okay, thank you.
I thought I saw another hand go up, but I'm not sure. Del.
Del Priester Cab. Well, what I was going to say is I offer a motion to accept this budget.
Ooh, a motion to vote. I love it. Is there a second?
I second.
There was a race to second. Okay. All those in favor, please raise your hands. Do me a favor. 1, 2, 3, 4, 5, 6, 7. Okay. Any nays? Any abstentions? Motion carries. Thank you, folks. All right. Yay, we did stuff today. That's awesome. Come on. Okay. Let me put these up. So before we adjourn, we have one little piece of business that we have to take care of, and then I'm going to turn it over to Deborah to give her final last words before gaveling us out. And that is, you folks had another vote earlier today, just before lunch, didn't you?
Yes.
I think I counted those ballots. Juanita, did I count those ballots? I did. She watched me count those ballots. Ms. Jackson, congratulations. Thank you. Okay. Deborah?
I just wanted to thank can y'all hear me? Deborah Crease, Chair. Just wanted to thank the CAB again for the meeting, for coming together, for recommendations. I'm so excited about what we did today. You just don't know how excited I am that it's helping us move forward, and I really appreciate that. And thanking all of you, and I thank James today. James did an awesome job. Give him a hand.
Thank you.
And this meeting is adjourned if there's no more questions.
All right, thank you, everyone. We'll see you next time.